Okay, so we're just waiting for Dr. Ash. Dr. Ash, if you can turn on your microphone and camera, that would be helpful.
So, Mr. Lilly, Dr. Ash is going to appear by video through Zoom, and then he's also dialing in on his phone through Zoom because we got much better quality on the break, if that works.
Excellent. Of course, I would prefer to have that.
So hopefully you have both lines connected, I guess, his audio and video.
Okay, let's see what we've got.
Hi,
We have,
Ted.
I
Can
see.
you hear me now?
Yes.
All right,
I
good.
think my staff is, I think they may have merged both into one display, but the video or the audio seems much better now. So thank you.
Good.
Okay, good. So without further ado, we'll put up exhibit MCWD 108. And Mr. Ash, I did give you the oath before the lunch break, so you're still under oath. And easiest thing, unless Mr. Wilkins interrupts, is just say next slide when you want us to go to the next slide, and you can go through your summary.
So, Mr. Lilly, during the break, we went through his slides and identified where they've changed. Would you like me to provide that to you now, just so that's clear for the record?
What do you think is easier, now or as you go?
I'm going to think it's going to be easier as up now, rather than trying to interrupt his testimony to explain where each of them came from, if that's okay.
Okay, why don't you go ahead and just do that right now?
Okay. So on slide 2, which is, you'll see a picture, the added text is a brief explanation for background. It's information you could find on the web or you could find in a geophysical textbook. So it is not something directly from his testimony, but it would be testimony he will explain as he goes through his slides.
Okay.
On slide 3, next slide. He added the text to the right there, and that is from MCWD page 9, lines 20 through 23.
Page, what exhibit?
MCWD 4, page 9, lines 20 through 23. So it's from his direct testimony.
Okay, so the site in the bottom is not correct. Okay.
The site at the bottom is the figure. And so he added the text, and he does not have a site to the text, just to the figures. Whenever you see a slide of the excerpt in the bottom, which will appear on each slide, it was from that will be to the image, which doesn't necessarily correspond to where it is on the page in his direct testimony.
Okay, all right, keep going.
Next slide. So this is page 4, and the he added the words to the right, not the image. The image was already there, and the text is from MCW 4 page 16, line 17 through 19.
Okay, keep going. This is just discussing changes.
Yeah. Next slide is okay. So the text is, the top part is, again, the image is the same. The text he added is there's 2 parts here. The top part is from page 26, line 7 through 9 of his direct testimony, MCWD 4. And the bottom part is from page 27, lines 26 through 28. I'm sorry, page 27, line 26 through page 28, line 2. And that's, again, from his direct testimony, MCWD 4.
Okay.
Next slide. There were no changes to this slide. Next slide. This here was originally 2 slides, and the first one is the images from as shown here in 2022, or it's from page 22. The second, I take that back, unless I mislabeled this. The one on the right is from page 22, and the one on the left is from page 24 of his direct testimony. They were both slides. Ted or Dr. Ash, if you can correct me if I'm wrong about this. They obviously both were originally slides. He just combined them together onto one slide. Did I get that
The
right,
other way
Dr. Ash?
around. Page 22 was MW4 and 24 was MW7.
Okay, thank you. Notes were wrong here. Next slide, please. There are no changes to this slide. Next slide, please. The text on the right is from MCWD 39, page 3.
Okay.
Next slide. And this is 10 of the slides, just to make sure we're keeping on track here. There are no changes to this slide.
Okay, keep going.
Next slide, slide 11. The only changes were he added the what's in red there, which is just the labels for the models, just so it was clear when he was discussing this.
Okay,
Next slide, slide 12. Again, both these slides were included. They're just a combined slide now. And so the one on the right is from page 47.
okay.
Next slide, page 13 of the slide deck.
Where does slide 13 is?
Is the first one is the same. The second one is from page 50, the next page. Again, both of these were slides, they're just combined. He did add the text on the top there that says 2017 AEM study, just so it was clear where it's coming from.
Keep going.
Next slide. The text on the right was added, and that is from MCWD 4, page 52, lines 8 through 12. Next slide should be 15.
Right.
The added numbers to the right there, that text is from MCWD 4, page 54. Next slide should be 16. Again, this is just a combination of two prior slides, so they are the 57 and 58 of MCWD 4.
Okay.
Next slide. So this is from page 59. The added red text, which you see there on the left, was added, and the black text, which says 2019 AEM study, both just descriptors, so you know where they come from.
Okay.
No substance changes. Line page. Next slide, slide 18. Again, the only change to this slide is where you see at the top it says 2019 AEM study, just so it's clear where it's coming from.
Yep.
Next slide. Slide 19. Again, it's the same thing. The red on the left where it says compare 2017, 2019 and borehole QA/QC with lithology logs, that is added descriptors. And then the 2019 AEM study, which is in black on the right, is added text.
Right, keep going.
Next slide. It's the same exact thing. The text in red and black and bold there was added just as a descriptor.
Right, keep going.
Next slide. And I believe this is slide 21, just so we're keeping a good record. There were no changes to this slide.
Right.
Next slide. He added what's in red there on top, and then where it's the R2, just so you could see what it says. So these are from the diagrams. He just added that text that's in a different color. And
Okay.
then the bottom reference was added from the 2019 report, the Fitterman reference, which is on MCWD in MCWD 29. Next slide. There were no changes to this slide. Next slide. The text at the top there, that 2019 AIM study, just the label was added.
All right.
Next slide.
Okay, keep going.
same thing. He just added that 2019 AAM study label up at the top right-hand corner. Next slide.
Are we on 26?
Should be on
No.
26 now.
Yeah, now we're on 26, yes.
Thank you.
And 26, same thing. He just added that 2019 AAM study label at the top. Next slide.
Okay.
Okay, this is the beginning of the 3 new slides he referenced in the beginning. And so 27 is from MCWD 29, page 133.
Okay.
Next slide. 28,
Okay.
that's from MCWD 29, page 134.
Okay.
Next slide.
Okay.
This is from MCWD 29, page 130.
All right.
And then there's 3 more slides, and the last 3 are all the same thing. That 2019 AEM study was added to the top as a label, no other changes to the slides. And that should conclude my explanation.
Okay, well, thank you. And here's what I'm going to do. I'm going to just go ahead and have Dr. Ash summarize this, and then Mr. Osias, at that point, I think it'll be a little easier to have the context, and I'll come to you and ask you if you're ready to go or if you want more time to refine your cross-examination. But you don't need to say anything now. Let's just go ahead and get started, but I will give you a chance to respond at that point.
I appreciate that. I just wanted to check with Mr. Wilkins. Did you, for 27, was it from Exhibit 27 or 29?
Hold on, hold on.
That was the first new one.
Slide
27
27.
is 133.
It's page 133, exhibit MCWE 29. It's in the lower right corner.
Right.
Thank you.
All right, thank you, Mr. Osias. So, all right, with that, Mr. Wilkins, let's go ahead and get started, or for that matter, Dr. Ash. I'm going to start the clock going now. So please go ahead and proceed with your summary. And if you just say next slide, we'll be more than happy to move the slides forward.
Mr. Lilly, before we start with his slides, I was wondering if I could briefly mark his CV and ask him to describe his professional and educational background, just for the record.
Okay, it's authenticated through his direct testimony.
It is.
So I'm not sure I think, didn't he reference it?
He did. And so I guess maybe just before he starts his slides, if he could briefly describe his educational and professional background to you, which is not part of his slide presentation.
Okay, go ahead. This clock is now running. Go ahead.
Good afternoon. I have a bachelor's in geology from the University of California, Davis in 1978. And then I moved to Berkeley and I took a course like Mr. Leffler in geophysics as an undergraduate. And then I moved into the geophysics department or sciences department at Berkeley in 1978. I was there for 3 years and I worked on 2 masters, finished one in the applied geophysics group. And then I worked for 3 years. Partially, I was in doing mineral exploration, and then I moved to the Negev in Israel for about a year and a half, learning about hydrogeology and the application of geophysics to that field. So then I came back in 1985 to Berkeley and worked my PhD on borehole to surface crosshole resistivity, DC resistivity. And then I worked as a private contractor for the next few years. And then I joined an exploration company, manufacturing company, training people in a geophysical technique called, I finished my PhD in 1990. I worked on with the company. We were working on a technique called magnetotellurics, which is a technique to look very deep in the earth. I was doing that. I went back and forth to Japan for about 5 years, 94 to 99, doing deep exploration for geothermal sites. In 1999, I joined the Army Corps of Engineers in Sacramento District, and I was based at Fort Ord, as it turned out, and I was in charge of directing the unexploded ordnance studies using geophysics. I was there for about 3 years, developed a lot of quality control, quality assurance techniques that are still currently used throughout the world. And then in about February of 2003, I moved to the USGS in Denver, the crustal geophysics group, continuing UXO work, but also developing new tools and working to a test site and other places, training geologic surveys around the world in basic geophysics. And then did that until 2013. And before that, I had gone to, in 2005, I was in charge of my first airborne EM survey was for the Army Corps of Engineers at the Tuella Army Depot, south of Salt Lake City. We were trying to map fractures and contamination moving through fractures. And then I've been continuing with different AEM studies since then and other things too. In 2008 and 9, I was involved, I was designing AEM surveys for Afghanistan to look at mineral exploration for different battles. There are about 11 different surveys we were planning to do until the funds were cut. And then in 2013, I left the USGS and joined a small company that is called Exploration Resources Geophysics. And there we basically were a geophysical contractor, mainly looking for water. I spent the summer of 2013 leading an investigation on the island of Pagan in the northern Marianas Trench. They're looking for basically trying to set up basically to monitor an active volcano as well as look for an unexploded ordnance around the island. And then in 2015, I left that company and started my current company, which is called AquaGeo Frameworks. I had two other partners. I have one partner now. And there we basically took our experience from the Corps and from USGS. The other two were also from USGS for many years. And we set up an airborne exploration group to basically develop hydrogeological frameworks for water agencies and private people, ranchers, farmers, whoever. And that's what we've been doing for the last about 7 years. And I think that's about it.
All right. Probably move on to your slides now.
All right. So next slide, please. So this is a schematic on the left of what the airborne electromagnetic technique is. You see the helicopter on top. I don't know if you can see my mouse or not, but basically you've got a helicopter, you've got a long, you see this big black loop that's horizontal. That is basically a long wire through which current travels. As that current is turned on and the direction it travels, it creates this, you have a current going through the wire, it creates a magnetic field. That magnetic field then propagates into the ground. When it gets into the ground, it gets converted back into electrical current. And as electrical current moves through the ground, it creates, it induces what we call eddy currents. Those eddy currents then create, again, magnetic fields which propagate in all directions. And there's a receiver back up at the back end of the transmitter coil that receives and measures those magnetic fields. And so this is basically electromagnetic field technique. Now, what's on the right is the equation that describes this whole thing is basically, it's called Maxwell's second equation. It's called Faraday's law. And on the left there, it says del cross E. So that's a spatial change in electric field is related to a negative time change in magnetic field. And that's the relation that's used to do this whole imaging effect. Now, what comes out of this, the measured quantity is electrical resistivity or conductivity, which is a measure of how strong the material resists the flow of electrical current. Different materials resist differently. And by correlating with other information, we can determine what those materials are. Now, the electrical resistivity is a function of pressure, temperature, the conductivity of the actual material the current is passing through, salinity, and the porosity of the material is passing through. And each one of these has an effect on your ability to determine what is that material, what's causing your response, and things like that. Next slide, please. So in 2017, we were asked by MCWD, it was Keith Vandermatten was the general manager at the time, And we basically just worked with Stanford University to do an airborne survey of the area east of the beach. Because in 2015, I believe, Stanford had done a DC resistivity survey along the beach, and they had talked, and the results came out okay. And so the general manager wanted to get that something could be done east of the beach, and so Stanford recommended airborne electromagnetics, and so we worked with the MCWD to look at the area they want investigated, and then work with Stanford on developing a plan for doing the investigation. Next slide, please. So,
Okay, just for the record, we're on slide 4 now. Please proceed.
So in the middle of May 2017, we flew a survey. These brown lines are basically the data retained after doing the acquisition. And so what happens is you acquire the data, and then you have to do quality control. The quality control involves before the system even gets to anywhere, it is tested at a home site in Denmark. We use the SkyTem is based out of Denmark. They do a test over their known test site. Then when the tool comes, say to North America to California, and it gets there, they unpack it, they set it up, they do some ground tests, make sure all the different instruments are working. That's the transmitter loop, there's altimeters, there's a GPS, there's a magnetometer that's on the rover, that's on the system, there's base station GPS, there's base station magnetometers. They test all that, and then once the data is collected, the QC that AGF performed involves looking at did the flight stay online to the planned lines? Did the pilot go at approximately the right height above the ground? They want to stay between about 30 to 50 meters off the ground for the platform. And then you have to look at how fast was he going? Because they should not be going much more than about 55 miles per hour, 80 to 100 kilometers per hour. You have to look at what was the tilt of the system. You want the system to be parallel to the ground. And so there's measurements of tilt, pitch, roll, and yaw to have to be checked. And then there is what we call the power line noise intensity channel, which measures as it says, measures the effect of power line and cultural infrastructure, because that will cause noise in your data, and you have to remove that before you do any analysis. Okay. Now on this slide also, one thing I forgot to mention in the previous slide, the orange line was determined by the Monterey County Water Resources Agency as the extent of the saltwater intrusion in the 180-foot aquifer. Okay, we just got this online, and then the light blue line is basically the extent in the dune sand aquifer, and the darker blue line is the extent in the upper 180 aquifer. Okay, and again, I think they came from the Monterey County Water Resources Agency.
The extent of what?
Saltwater intrusion.
Okay.
Or actually, I think no. I take that back. The orange line is saltwater intrusion. The light blue line and the dark blue line are the extent of what they were calling anomalously low TDS.
So are these from Monterey County Water Resource Agency?
I believe so.
Okay. All right. Please proceed.
Next slide. So one of the first things that had to be done was determining. This is basically a resistivity cross section. On the left, you can see the MW4D, MW7D. The numbers below those are the distances of the AEM from those wells. These are basically the resistivity profiles after the inversions. And the purpose of this was one of the first things we had to do is determine where's the water table at. And in the area, it turns out that my understanding is that only the MWSP wells had good water table measurement data. And so that's the bottom in the MW4, MW7, the bottom of the gray is the top of the water table in those wells. So then we said, okay, if that's what that is, and resistivity at that depth was 75 ohm meters. Okay, and so in the bottom section, everything above 75 ohm meters has been removed. And so you only see in this section everything that's below 75 ohm meters in resistivity. And so what you see a top thin layer up here, and then you see a deeper thin layer here. Over here, the red is very conductive. The resistivity scale is down here. Okay. Now, one thing to note is that the 75 ohm meters that was selected, it's an approximation. And basically what this paragraph down here says is that if there's a resistivity greater than 75, which we've interpreted as unsaturated, there could still be fresh water above 75 ohm meters. So it's an approximation. And then alternatively, it could be that for regions that there could be unsaturated material that has a resistivity less than 75 ohm meters. So again, this is just an approximation to give us an idea about where the water table is and separate out the unsaturated from the saturated material. Okay, next slide, please.
Okay, and we're now on slide 6. Go ahead.
Okay, so these are just 3 example cross sections. You see on the right the images of where they're located, and what's of interest is that the BB prime in the center, the western end of that is not far. It looks like about, you can see on above the image that, like say next to MW7, it says 702 meters away, which is maybe about half a mile, 0.4 miles away from these wells. So we're within about half a mile. So this section is on the west end, it's about half a mile away from the MWSP wells. And what's of interest is that, for one, you see a thin blue strip here on top of the section, and then you see that it comes together with the lower blue strip right here, or on the western end here. There's some data cut out, but they seem to point to come together. Okay, that's of interest. Next slide, please.
All right, this is slide 7.
The next thing is that you want to compare the airborne inversion results to the geophysical well logs in the area. So here we just chose, these are MW4, MW7. The brown line is the borehole geophysical log, and the kind of the stocky blue line is the nearest inversion, airborne inversion model, and the kind of the soft blue line is basically kind of an interpolated of the nearest airborne resistivity soundings. Okay, that's for MW4. And what you're looking for here is how close in the general trend does the airborne models match the borehole log? And they seem to match pretty well. So at the very top. And then over here on the right, MW7, again, the blocky blue line is the AEM inversion model, and then the brown line is the borehole. And basically, you're looking for general trends. Are they in the same ballpark of general trend? Now, one thing of interest in MW7 is this resistive zone that's in the borehole log that would likely either be, and it says on the right here, this right section, the green sections are the screen zones, and the right are lithology. And these basically on the right here for this, we're looking at a lot of sand and a little bit clay, maybe silty clay. But what's of interest is that there's a resistive zone here, which could be of interest to somebody. Next slide, please.
All right, here's slide 8.
So the next thing, once the AEM is compared to the borehole geophysics logs and they seem to match, the next step is to come up with some relation that you want to compare the airborne resistivity models to the water quality. And so some research was done, and that the Stanford, they came up with this table, which basically came from 2 sources. This California State Water Resources Control Board from 2006, Title 22, Article 16, where they had a drinking water was in 0 to 1,000 milligrams TDS, and source of drinking water is from 0 to 3,000. And then the US EPA published, I guess, a report in 1988, which says 3,000 and 10,000 is water of potential beneficial use, and greater than 10,000 is water of limited beneficial use. So we took these as our groupings to try to compare the airborne resistivity models to water quality that was that was published by the state and the federal EPA. Next slide, please. So
Slide
then
9.
the next thing was to then come up with resistivity ranges, airborne resistivity ranges, or just resistivity in general, that could be related to the water quality groupings from the previous slide. And so what was done was we had the data from basically the 7 wells, the 7-well clusters, MPWSP, with 3 wells per cluster. It gave us 21 water quality measurements. And then what Stanford did was they looked at each screen interval, and they looked at the borehole geophysical log, and the borehole geophysical log had a sampling interval of 15 centimeters. And what they did was they made a histogram plot of at each interval what was the resistivity and what was the water quality for that zone. And then they plotted that up, and they came up with this figure. And basically what they ended up with is that less than 3 ohm meters, this kind of dark orange is greater than 10,000. Less than 3 ohm meters is going to be greater than 10,000 milligrams per liter for TDS, so the water of limited beneficial use. And then greater than 20 would be the cutoff for source of drinking water, so less than 3,000 TDS. Now you'll note that there's some pink area or purple area here, which is basically the zone 3,000 and 10,000. And these points right here are from well MW9S, the shallow screen. And the points were around about 3,204. And so they are basically, because they're above 3,000, they're in the pink purple zone, but they're pretty low in that zone. And so you see all through here for these zones, these are approximations. There's overlaps to different groupings. So we took these, again, as I say, conservative estimates of, so less than 3 is greater than 10,000, and greater than 20 ohm meters is going to be in the less than 1,000 group, or less than 3,000 group. 20 to 75 ohm meters will be less than 3,000 milligrams per liter. Okay, next slide, please.
Okay,
And
this is slide 10.
Example. This is just an example. You see this red line, that's where this profile is from. And the idea was to see, here's the legend tells you about the different hydrostratigraphic units. And you can see here's a gap in the 180-400 foot aquitard. And so we could see and this is kind of called its original. And then this is an overlay of the resistivity data on top of that profile. And you can see that there was a big drop here in resistivity. So they figured there must be a gap, because there now is a connection between the 180 and the 400 foot aquifers. So there's a gap in the aquitard. Okay, next slide, please.
Okay, this is slide 11.
And this is a summary, so we're not going into super detail, but what was developed was that Stanford developed basically 2 groundwater sections, one based on what they called published data, which was like Kennedy and Jenks and MacTech and Harding Lawson and USGS, and came up with a basic stratigraphic section based on their information and well data. And then there was a second profile developed that was based on the North Marina groundwater model. And there were enough differences in the thicknesses and nature of the different stratigraphic units that they separated into 2 models. So what you see here, then they called what they said as a pre-AEM model, where they had the models they got from the different sources, and then the post-AEM models is overlaying the interpreted airborne inversion results on top of those sections. And now, so this is a slide of cross-section 2. And in the map up here, cross-section 2 is right here. And you can see it is only probably about a half mile, the western end is about half mile south of probably the CMEX property. And that's over here. So when we take a look at the sections, either section, what we see here, and what you see on the logs here, these are lithology logs. What we see here is we see a thin blue section on top, and this purple is the Salinas Valley aquitard. And you can see, as we've seen in a lot of figures last week, it thins out to the west. But what you see in that this is probably the Perched A aquifer, but what you see is this thin blue section meets with this other section here, which looks to be the upper 180 aquifer, because we're south of the Salinas River. And what we see here, then we have this basically water, potential drinking water, so a source of drinking water, less than 3,000, and below it is the greater than 10,000 material. All right, next slide, please. And so once we had that,
Slide 12, go ahead.
What Stanford did then was develop kind of spatial thickness maps of material. So these are going to be, this is the source of drinking water, so less than 3,000. And this on the left here is a distribution of dune sand aquifer material that is less than 3,000. Okay. And then on the right is kind of a similar map, but this is the upper 180 as a source of drinking water, the spatial distribution from the 2017 study. All right, next slide.
Okay, slide 13.
Okay, so then what Stanford did was they came up with basically they tried to determine volumes, and they basically provided two estimates of volume. One, the first estimate in this column is is basically the limited beneficial use. So this is the volume of material that was greater than 10,000 milligrams per liter. The next column, it says source of drinking water. So this is going to be an estimate of volume of the less than 3,000. Now, the next step was, okay, that's the volumetric of everything within that volume. Now, let's say we had a 20% porosity within that volume. And this 20% came from somebody named Stetter, who published something in 2000, which made that provided that estimate that they used. I don't know that paper, I'm not familiar, but that's where it came from. So they estimate they used a 20% porosity of this volume, and they came up with basically, for this case, 7.49 cubic meters, okay, times 10 to the 6 or 8, whatever it is. Okay, and that's what so basically these are just estimates of volumes and then an estimate of source of drinking water, just estimates. And this is a 2017 study. Okay, next slide, please. So that's where things sat for a couple of years. We got a call from MCWD, and they wanted to take another look at the area. And so this time, though, we decided to use, and they also wanted to extend it to the south to include some Fort Ord source material. They thought that there was water flowing down from Fort Ord into the Salinas Valley, and they wanted to see if we could image that. So because of the nature of the area, we decided to try a new system called the SkyTem 312, which basically is a deeper imaging system, not by a lot, but enough to maybe help a little bit here and there. So we use SkyTem 312, and so in April 24th to 26th of 2019, we basically flew 881 line kilometers, about 544 miles through the area. Okay, next.
This
And
is
these
slide
are the well
15.
logs. These are the well logs we used. Basically, they mostly came from the 318 that were used for the 2017 study. And of these, 186 were lithology logs. We used 36 geophysical logs. You can see like a green center in some of these different red circles. And then from Fort Ord, we received about 84 lithology and geophysical logs, mostly lithology, from Fort Ord. And so this is what we used for the analysis. Now, one thing I want to note is that for a lot of the AEM studies, we don't have nearly this concentration of wells. This is a very strong concentration of well data for correlation to use. Very strong. Just take my word for it. A lot of studies will have a tenth of this will be called good. And to have this many is very good for correlation, for determining what's going on in the area. It's a complicated area. Okay, next slide, please.
Slide 16.
So again, we compared the airborne to the well logs. In this case, we're using the original images from the 2017 report, and we're overlaying this red square line, which is now the 2019 inversion. And you notice that in MW4 in the near surface, about 15 to 20 meters depth, it's gotten a bit more conductive. That's interesting. And then over here in MW7, again, it matches up pretty well. We see there's a slight difference right here right at the base of the shallow screen in MW7. It's a bit more conductive than it was in 2017. All right, next slide, please. But they match up pretty well.
17.
So then the next thing is now we look at over the whole area. We create these 2D profiles, we overlay geophysical logs, here's the resistivity scale, and what you're looking for here is does the red overlay the red, does the green overlay the green? And we're not going to get some of the high detail that we see in the borehole logs, but generally are they kind of overlaying, how close do they look? Is this area green on some well? Why is that? Then there's an issue there. But here they match up pretty well. So the geophysical logs and the airborne match up well. So we have pretty good confidence in the airborne geophysical inversion, resistivity-wise. Next slide, please.
Okay, slide 18.
And so then part of the analysis is we basically create all these profiles, and then we create a basically kind of a profile screen, and basically we put them all together, and we just look at the general area. Do things kind of match up? Do they kind of make sense? We knew we were in some high resistivity areas over here, so we got some high blue stuff. We've got some blue on top of some red, and we know along the beach there's a lot of salt water, so we're getting some deep red. So things basically make sense. Okay, resistivity-wise. Next slide, please.
Slide 19.
So then the next part of that, once the geophysical logs match up, let's take a look at the lithology logs. And in this case, we're overlaying lithology logs, but we're also comparing the 2017 data to the 2019 data. How do the inversions look? And here along the beach, this red line in these upper figures, they compare pretty well. There's some slight differences here and there, but generally they match up pretty well. So that's good. Not really no real major changes in the area. Next slide, please.
Slide 20.
Now one thing of interest is that here's a line kind of perpendicular to the coast, inland a little bit, and you note in the 2017 this is the 400-foot aquifer. You see these red sections, which means that they are there's some pretty low resistivities, which are probably due to saline water. But you see in 2019, you see a little bit of expressions of them, but not that much. So this says there's been a change between 2017 to 2019 along this line at the 400-foot aquifer. Okay, next slide, please.
Slide 21.
Okay. So then the next thing is, once we've got an idea, we believe in our data, things are matching up pretty well. Now let's try to use the resistivity data, airborne resistivity data, to then correlate it with the water quality data, and if they have water conductivity data. And so here are the MWS wells. The second column is the lithology in those screens. And you see this called table 4-5. So initially, and this is from the 2019 study, initially I used this data that was called specific conductivity. And in a lot of places, when you're comparing water data, they call it specific conductance, specific conductivity. And so, okay, I'll use that first. And so initially, I compared the mean AEM mean resistivity data from the different screen intervals to the specific conductivity. And when I first ran the correlation, I didn't do any kind of call it normalization of the data. I just used this data and this data. I got a R squared, which is a measure of we heard last week is a measure of say model fit. We got an R squared about 0.53, which is not very good at all. Okay, so then the next thing I did was I normalized the data and I took the natural log of both sets of data. And then here's LNEC here, what I call EC, and here's the airborne. To do correlation of that, and just by doing the normalization, the R squared went from 0.53 to 0.66. So okay, well, that's good, but now why is it not better? Because I want to see it around 0.85, 0.9 or higher. And so what I started doing was I started looking at individual data points that were far away from the line, regression line, the trend line, and take them out. And in the end, I got to a regression of about 0.96 by removing 6 data points out of the 24, which is, it's good to get a 0.96, but it's not too good to remove 6 data points out of the 24. So then I said, okay, what else? What other data do we have? Well, there was this other data column, actual conductivity. Now, one thing of interest, I added in this data came from the MPWSP water report, like number 160, that was from April 10th to May 15th. And I looked at our time of measurement for the airborne was April 24th to 26th. So I picked some water sample data. This water sample data is from April 24th at 12 p.m. And that's where this data came from. And so then, but the thing was, the labels of the columns were just micro Siemens, so mu S. And typically conductivity is always in micro Siemens per centimeter or meter, and resistivity is in ohmmeters. So there was this kind of fishy right there that both the specific conductivity was micro Siemens and the actual conductivity were micro Siemens, but I know they really should have been micro Siemens per centimeter. So I just, some people make errors like that, that's fine, it's okay. So then what I did was I went through the same process again of the correlation. I converted what's called actual conductivity from micro Siemens per centimeter to Siemens per centimeter to Siemens per meter. And then you take the conductivity and resistivity are reciprocals of each other. So I took the reciprocal of the actual conductivity, Siemens per meter, and that gives you ohm meters. So then I took the natural log of now the what I call rho W AC, and I got these, and I did regression correlation between the natural log of rho W AC and the natural log of my mean airborne resistivity. Okay, next slide, please. And
Okay,
so
slide
these are
22.
the equations. These are the equations that came up. On the left is the relation. You see rho ln rho em down here on the x-axis, ln rho w ac on the y-axis. This is the correlation, and what came out was a 0.89, and that was after removal of only 2 data points, not 6. So just 2 data points gave me a 0.89, which I think is very good correlation. On the right is basically taking that rho WAC, what I got from over here, and I correlated it with the salinity and the TDS values from the water sampling. And here we got 2.99 R squared. So very good fit. So I would use these 2 relations to correlate the airborne Earth model inversion results to the water quality TDS. And now this process was not created by me. It was first presented by a fellow named Dave Fitterman and Scott Prenos in 2011 for the USGS. And they did this in Southern Florida. They came up with this 2-step process. And we've used it several other places, and it works well for doing these correlations. Next slide, please.
Okay, slide 23.
So this is kind of a summary table. It has the same column as before, but now we've added a few more. And in this column right here, it says cut. And the X was what the data I cut out when I used the data was called specific conductivity. And the blue for M4S and MW9D is what I cut out when I used what they called actual conductivity. Only 2 points, and I got a 0.89, which is very good. And so over here on the far right, you see what I call predicted. So this is the predicted measure EC, and this is predicted, and then this is predicted TDS values. So just estimates, but they show pretty good except for a few of them, like here for 4S and 9D. Okay, next slide, please.
Okay, we're to slide 24.
So the next step is to apply those relations to all the data, and you come up with, here's our resistivity sections and we have here on this section, we have both geophysical logs and we have lithology logs. And like right here, you've got lithology overlaying geophysical logs. And the top section is a resistivity. The bottom section is the estimated chloride concentration or TDS value. These are, either one, TDS or chloride. They're different, but they're just estimates. And here again, so and we broke it up into a color range in these different 5 groups: 1 to 250, 250 to 1,000, 1,000 to 3,000, 3,000 to 1 to 10,000, 10,000 to 19,000, and 19 to 40. And we use these 19s because that's kind of what seawater is usually, around there. Okay, and so basically we did this for all the data, for just 2019 data. And then the next slide, please. We then
Okay, slide 25.
So then the next step was to then apply it to the 2017 data and then compare the 2017 results to the 2019 results. So this profile is a little bit inland on the north side. And you can see that they match up pretty similar, but there's a few differences here. We had a little bit better water quality in 2017 at this location along that line than we had in 2019. But otherwise, they match up pretty well. So we did this for all the data sets. Okay, next slide, please. And then out of that, out of the different sets of data, we create a voxel, 3D voxel. In this case, we're looking at the 2019 data. The color scale is their estimated chloride TDS. I call it chloride because that's what I'm used to looking at elsewhere. So, but it could be It could be chloride / TDS. I think in this case it should be TDS. But I was just so used to putting chloride. I call it chloride, but it should be probably TDS. And then this is all the resistivity data. And what you can see here, this is the CMAX plant's about right here somewhere. And then you can see here we've got a blue area sitting on top of kind of a reddish and yellowish areas. Okay, but we still need to apply the 75 millimeter cutoff. So next slide, please. And so what we do here is we basically we take all the resistivities less than 75 millimeters, and then we also break it up such that we're only looking at the range from 1 to 500 milligrams per liter, which is kind of the blue area and gray area, and then greater than 10,000, which is these brown and red areas. So it's only the zones you're looking at. And here again, so this is within the water table, estimated water table, sitting on top of brown, of greater than 10,000 material. And that's in 2019, and this is in 2017. They look quite similar. There's other differences in the area. You can see the differences up here in the 10,000 distribution and the 250 to 1K distribution. There's fresher water. Next slide, please.
Okay,
And
we're on
this is
slide
just
28.
Just another view. You've got, this is again the 1 to 500. This is 1 to 250, 500 to 1,000. Blue sitting on top of brown, and so this gives you an idea of the water range of the basically the TDS ranges within the area. Next slide, please.
Slide
And then this
29.
is another section view. Again, you're looking at the basically the 1 to 500 zone over a 10,000 or 3,000 to 40,000 values. All right, next slide, please. And then
Slide 30.
the final step was to then plot up the zones. Here's 20 to 75 millimeter data, and this is within the dune sand aquifer. And so here you see the distribution. You've got stuff coming out of Fort Ord, which is probably not part of dune sand. Maybe it is, I don't know. And then you've got this area, this calamsite right here, and this is in the dune sand. And note this little blue line here. This came from EKI, Vera Nelson, as what they were calling the dune sand freshwater capture zone. And they gave it to me and I plotted it just to see where it lands, but I have no knowledge of it really. And then this is for the 2017, 2019, similar plots. Next slide, please.
Okay,
This
slide
is plotting
31.
This is plotting up all the resistivities, and this is for the upper 180 aquifer, 2017 on top and 2019 on the bottom. And you can see that again, we've got this conductive material over here, and we've got this resistive material over here. This is within the upper 180 in 2017, and it's still there in 2019. Next slide, please.
Okay,
And
slide
this
32.
This is the 2017 lower 180 on top, the 2019 lower 180 on the bottom, and then here you see that it's much more conductive. So there's a big difference between the upper 180 and the lower 180 between in the area. It's similar for both 2017 and 2019. And I believe that's my last slide.
All right. So, Mr. Wilkins, does that conclude? That was 45 minutes. Good whirlwind summary. Thank you. So, Mr. Wilkins, do you have anything else, questions for Dr. Ash on summarizing his direct?
Knowing the length, I might ask one question if you'll provide the indulgence.
All right, go ahead.
Can you explain, Dr. Ash, if salinity and lithology are generally variables in most AEM studies, or how often is salinity and lithology a variable for the AEM studies you've worked on?
In every AEM study, those 5 variables are listed up top: pressure, temperature, the conductivity of the material, the salinity, and the porosity come into play. You cannot ignore any of them ever. And so you need to take it. So typically, depending where you are, like I've done surveys on the ocean bottom where the temperature and pressure are a big factor on the conductivity. But on the Earth's surface, the pressure and temperature are usually not variable, and so you can kind of dismiss those. So then you're looking at the conductivity of the material, and then the salinity and the porosity of the material. And so you need to take account of those every single time, because places that you wouldn't think, like if you're doing saltwater intrusion studies, okay, we know we got saltwater, so salinity is going to be a big factor. We also have to consider lithology, but there are other places. I've done a survey in the Central Valley near Merced, where we were mapping for a rancher. He wanted to know where to drill for freshwater resources, and we did the airborne survey, and we found his fresh water, but we also found saltwater at depth, a large zone of saltwater at depth, which we estimated was from when the Central Valley was an inland sea, and that was left over from that time. Okay, but salinity and porosity and lithology are important factors that go into your recidivity determination, and you have to consider them every time. And so the way you get around that, or the way you deal with it, is you try to have a borehole control. You first check that all the quality control of your actual measurements are good, and those are satisfactory. Then you go to your borehole geophysical logs and borehole lithology logs and water quality logs, and then start making correlations of what's what, who's related to what, what's causing what, do things make sense or don't make sense.
So, Dr. Ash, Mr. Wilkins asked you about lithology, but you gave an answer in terms of your 5 variables, none of which are lithology. So can you relate lithology to the 5 variables you've mentioned?
So lithology would fall under the material conductivity. And the reason I didn't call it lithology conductivity was that we are making a volumetric measurement. So the current is going through a volume. And that volume could be a straight lithology or salinity or whatever, but it also could be going along a fault zone. And that fault zone will affect our conductivity of that volume. And so I don't want to call it straight lithology, because then I'm not taking into account geologic structure. So we basically call it material conductivity resistivity to incorporate both lithology, salinity, porosity, and geologic structure.
Okay, and is porosity part of lithology?
It is in a sense, it's a part of a rock. Your lithology can be, it's the constitution of a rock, say clay or sand. So you have sand. Well, those sand grains are sitting next to each other, but there's spaces in between those sand grains. If you have very fine sand, you're going to have a very low porosity, very small spaces between the fine sand grains. But if you have a very coarse sand, you're going to have a larger space between those sand grains. So you can have a larger porosity.
Okay, well, I understand that, but it sounds like the lithology, if by identifying what materials it is, will give you some indication of porosity. Is that correct?
Lithology, I would say you need to take it into account. That's why it's a separate factor, because you can't just say, well, if it's sand, then it's going to have this porosity. You need to know if it's fine sand, coarse sand, cemented sand, silty sand, clay sand.
Okay, that's good. All right, so that's it. Mr. Wilkins, I assume that concludes the summary?
Yes, thank you.
All right. So, Mr. Osias, you're up next. Well, thank you, Ms. Mullen, for taking that off. How do you want to proceed here. We can, I think it's a good time to take a break to let you regroup, but do you have any comments? There were some edits to these slides, which you learned about for the first time. So what's your comment on how to proceed? How you would like to proceed? You
All right.
have to go off mute. There you go.
The first time I'm actually officially doing something and I left my mute on. I apologize.
That's fine.
I heard Mr. Ash say something that I would like him to confirm or not, to know whether it's a change in the slides or not. I think he said, and you can check me if my hearing wasn't right, that from on slides 23, and then it continued all the way through 29, the labeling was chloride, but he said something like, it probably should be TDS. And I just would like to know whether those slides are in fact TDS or chloride. I think the original slides also said chloride. And if it's not chloride, then we should correct it. And I'd like to know that before I respond. Did you hear that too?
Why don't you go ahead? I see that the labels in the legend for slides 24 through 29, wait a minute, at least through 28, all refer to chloride concentrations. And I did hear Dr. Ash, you said something about should be TDS. So could you please just clarify for us what you meant when you said it should be TDS?
Yeah, those should be TDS.
So the numbers that are displayed here are actually TDS values?
That's correct.
Okay.
I use the TDS equation.
Okay.
I'm so used to working in other places where we're looking with chloride that I just automatically call the chloride. Sorry.
And so your counting was better than mine, Mr. Lee. I think, is that affects slides 24 through 29? Is that correct?
I don't see, I see it through 28.
Okay.
I don't, oh, no, and 29, you're right, chloride. So is that right, Dr. S? 24 through 28, we basically should change the legend from chloride to TDS?
Yeah, 24 to 24 to 29, yes.
To 20.
Okay.
But
Okay,
the numbers are right, just the label's wrong, correct?
That's
so
correct.
Mr. Osias, yeah, to understand, the units are actually units of TDS, is what you said. Is that correct, Dr. Ash?
Yes.
Okay. All right. So, Mr. Osias, I'm certainly going to take a break now of some reasonable time, like 15 minutes. Will you be prepared to start your cross-examination after that break?
Yes.
Mr.
Okay.
Lilly, apologies for interrupting. This is Joseph Malk for the city. We were intending on asking some examination questions of Dr. Ash as well. I was under the assumption we'd be going before Cal-Am, but whatever you would prefer.
Thank you. That actually is important. Do you have any time estimate for your questions?
I would estimate 15 minutes or so. Certainly we'll be well under the half an hour mark.
Okay, so thank you for interrupting. Let's go ahead and do that right now. And before our break, and then we'll shift to we'll have our break, and then Mr. Osias for cross-examination will come after that. So, all right, so Mr. Malk, is it Mouch?
Like a K, Malk.
Malk, okay, if you may proceed and let us know which slides or exhibits you want us to screen share.
Certainly, thank you, Mr. Lilly. Good afternoon, Dr. Ash.
Afternoon.
My name is Joe Malk. I'm an attorney representing the city of Marina. Your testimony is dense with data, so I was hoping to ask you just a few questions to try to cut through and hope that I understanding correctly some of that. Did I hear you correctly a few minutes ago explain that your first use of AEM technology was back in 2005?
That's correct.
So this AEM technology that you've been describing is technology that's existed for at least 17 years. Is that accurate?
It started being developed about 1998. The technology we're using here started being developed in 1998. Airborne geophysics has been used for probably close to 100 years, okay, for mineral exploration. For groundwater work, is a whole different kind of technique you needed, and that started developing 1998, and it took them a few years to develop it in Denmark, and the first survey I think they flew was maybe 2003, 2004 over the Galapagos. We were like the first or second survey in the US, in North America, in 2005 in Tooele.
So do I understand correctly that in that context of groundwater analysis or hydrostratigraphy, that you've used the AEM technology in situations other than just these two studies that you've testified to today?
Yes, quite a few.
And you mentioned that at least one use in that context was by the USGS in South Florida in 2011. Is that right?
You're asking about the Fitterman survey, and that what they did survey that data. I'm not sure when they did that data. They did surveys in the mid and late 90s. I'm not sure about when else that Fitterman survey was done. But the USGS is doing other. I was with the USGS for 10 years, and we did surveys all over the US for groundwater work in all over many states.
And when you say you did surveys at USGS, do you mean AEM surveys?
Yes, AEM surveys for groundwater frameworks development.
Thank you. Did I understand your testimony correctly that the AEM studies that you conducted here revealed certain information about hydraulic connection between the dune sand aquifer and the 180-foot aquifer?
Now, I'm not one to talk about hydraulic connection because it's not my area. But what I can do is I can look at the resistivities and say, these resistivities come together. Now, we'll take a hydrologist who would look at it and say, well, that to me, that means there's a hydraulic connection. I acquire the data. I try to provide the best quality data I can, and then it's up to hydrologists to look at it and then come up with what they think is going on.
Okay, so what did the AEM data reveal in terms of the gaps or thinning that you saw that a hydrologist could then make those determinations based on?
Are you a clarification? Are you asking about gaps or are you asking about hydraulic connection again?
Sure. I'm asking generally, as I understood it from what you just testified to just now, that while you can't speak to the ultimate determination, what you saw based on the AEM studies was data or information that you thought could lead a hydrologist to make that determination. So my question is, what was that information or data that you saw?
Oh, we looked at you look at those sections, you look at the distribution of the resistivity in the profile sections, and if you could see where you see the same level of resistivity, color resistivities come together, you've got a connection there between those resistivities. Now, what that actually means in terms of hydrology is something else. In terms of gaps, again, you're looking at different zones of resistivity, and some places where they thin out means that there's a geological unit that is thinning out, and if it becomes discontinuous, there's a gap in that unit, and that's what the resistivity would tell us.
So, Mr. Lilly and Ms. Mullen, if you could share MCWD Exhibit 4, that's Dr. Ash's testimony.
We'll be glad to screen share that. Tell us what page you'd like us to scroll to.
Yes, please. Page 12.
All right. And we will go to page 12. Tell us what line you want.
Yes, if you could scroll to the bottom of page 12, and it is lines 26 through 28.
Okay, we have that on the screen.
Dr. Ash, is this portion of your testimony addressing the data that you saw in the AEM studies regarding the resistivity shared between the dune sand aquifer and the 180-foot aquifer?
I would say where this came from was from this, look just before that, the groundwater, you see this Otna Environmental Inc. 2017. I believe that Stanford looked at that report and they came up with this description of what is going on in these areas. And you could look at the resistivity, hydrologists could look at our resistivity distribution and say that maybe confirms what this is saying, but that's up to the hydrologist to come up with that.
Thank you. Am I correct that
Do you want to, are you done with this exhibit? Should we take it down or are you going to scroll further?
let me ask him one more question in that regard. Thank you, Mr. Lilly.
Okay, go ahead.
If you look at the sentence that begins on line 26 of page 12, Dr. Ash, it reads, the flow of groundwater from the dune sand aquifer to the upper 180-foot aquifer appears to mound groundwater in the upper 180-foot aquifer near the coast, creating a local groundwater barrier against encroaching. If we scroll now.
Oh, we can scroll to the next page. One more word, seawater is on the next page.
Saltwater.
Saltwater, yes, thank you. So what's your question?
Yes, can you explain what that sentence means, Dr. Ash, in the context of your AEM results?
Please scroll back up a little bit. We can see the sentence.
Yeah, there we go.
So if I was a hydrologist and I read this sentence, then I would look in that area to see if there is resistive material or am I seeing conductive material. If I'm seeing resistive material, that would tend to me that it could be mounding of some water of some sort at that zone and it's more resistive. So it may not be saltwater. So, but that's up to hydrologists to look at and determine what they think those resistivities are representing.
Sure. And I understand.
And just excuse me, Mr. Mount, but when you say resistive or conductive material here, Dr. Ash, I assume you mean resistive or conductive hydraulically, not electrically. Is that correct?
No, I only think electrical resistivity. So
okay, good. I appreciate that clarification then. But then why, so the hydrologist should look for those materials to see whether they have electric resistivity or conductivity?
Yeah, so if they want to look at the resistivity, if it's less than 3 ohms or is it greater than 20 ohms? So
okay,
if it's
thank
greater
you.
than 20, it could be a source of potential drinking water, or if it's less than 3 ohms, it's going to be highly saline water.
Okay, thank you.
I only think in electrical resistivity. I don't think anything else.
Okay, go ahead, Mr. Mauk. Hope I'm saying that right.
You are. Thank you, Mr. Lilly. And that was a perfect segue to my question, which was going to be just to step back to some of the most basic level here. From what you were testifying to a moment ago, what we should be thinking about when we hear in your testimony and reading your testimony is, am I correct that fresh water or fresher water is going to be more resistive, less conductive than salinated water, which is going to be more conductive and less resistive? Is that correct?
That's absolutely correct.
I'm done now with page 12. So thank you, Ms. Mullen.
Are you done with this exhibit for now?
For the moment, yes. Thank
Okay,
you.
we'll go ahead and take that down. Go ahead.
Dr. Ash, am I correct that in the AEM studies that you've testified to today, you divided groundwater into different categories based on the concentration of total dissolved solids, TDS, in the groundwater?
Yes, according to the state and federal EPA.
And if we look at that exhibit 108, which is your slides, and particularly slide number 8.
Okay, we'll put up MCWD 108, slide 8, did you say?
That's correct, Mr. Lilly.
Okay, slide 8.
And Dr. Ash, these are the 4 categories that you just referred to, correct?
Correct.
So in your understanding, these 4 categories, which are drinking water, source of drinking water, water of potential beneficial use, and water of limited beneficial use, those are all categories of groundwater. in terms of how you conducted your study. Is that correct?
They are categories defined by these agencies, and we were doing a correlation to resistivity.
Categories of groundwater, right?
Yeah, the groundwater term in this report, yes.
Thank you. That's it for slide 8. Thank you very much.
Okay, go ahead.
Did I also understand from your testimony, Dr. Ash, that the AEM studies revealed certain information about the volume of groundwater in the category of source of drinking water in the dune sand aquifer?
Yes, one of the estimations that Stanford did for 2017 was to come up with estimations of volume for the different stratigraphic units. And that included the source, one of the source of drinking water.
And then same question, that your testimony is that the AEM studies revealed information about the volume of groundwater, but also in the category of water of beneficial use in the dune sand aquifer?
Limited beneficial use. The word limited meant that is referring to the greater than 10,000 milligrams per liter.
So am I correct that there's two categories there? One is water of beneficial use, and then one is water of limited beneficial use, correct?
Well, Ms. Mullen, let's go ahead and put the slide back up. Sorry, I think we encouraged you to take it down too soon. But we'll put back up exhibit MCWD 108, slide 8, because I think they're listed here. It might be easiest for
Actually, you want to go down. Probably about slide 15 or something. Go down.
Oh,
It's right there. Slide 13.
okay, that's the one with the volumes. Go ahead, Mr. Mount. We now have slide 13 of exhibit MCWD 108 posted.
So look at the top of the column, and the third column says total volume limited beneficial use, which translates to greater than 10,000. And then the fourth column says total volume source of drinking water. So according to that table from the previous, is less than 3,000 milligrams per liter.
Understood. So there's, based on the studies that you conducted with the AEM technology, and then that information was taken to then develop these volumes, these volume estimates. Is that correct?
That's correct.
And the categories here are the categories based on those TDS ranges that were in the prior slide 8 that we just looked at a moment ago, correct?
That's correct.
If you could, Ms. Mullen, bring back up the MCWD4, Dr. Ash's testimony, and in particular, page 76 of that exhibit.
Okay, we will post exhibit MCWD4 and go to page 76.
Thank you. Dr. Ash, if I could have you take a look at this page of your testimony, and in particular, if you could look to starting at line 15.
Okay, we'll scroll down a little bit here. Go ahead.
Perfect. Thank you very much. It says here, note the presence of higher resistivities, parentheses, fresher water, within the CalAm site location and the bounds of the dune sand freshwater capture zone for both the 2017 and 2019 AEM resistivity inversion results. It refers to figure 482. And then the next sentence continues, in figure 483, note the reddish colors indicating more conductive material within the lower 180-foot aquifer period. The information in these two figures indicates that there is very likely fresher water overlying more brackish water just within the CalAm site location and progressing inland. Do you see that?
Yep.
So can you explain how the AEM results, or the AEM studies that you conducted and the data that they provided, how they informed what's written here regarding the presence of fresher water in the dune sand aquifer in this particular area just within the CalAm site.
Okay, can we scroll down? I think probably the next page is figure 482.
Okay, the next page first has figure 480. Do you want that, or
Oh,
farther
480.
down is figure 482?
Yeah, go down 482, it's fine.
Okay, we'll scroll down. This is the second half of page 77 of exhibit MCWE4.
Okay, so these were in the 108, exhibit 108, the presentation. So these are from 2017 and 2019, the resistivities plotted that were within the upper 180-foot aquifer. 2017 on the top, 2018, 19 on the bottom. And if you look within the region, that blue zone that we got from EKI, that's called dune sand freshwater capture zone. Doesn't mean it's within 180, but just gives you a location. It shows that in both 2017 and 2019, within that, and you see a little red square there, rectangle that says CalAm site, that just at the top of that rectangle, you see blue colors. So we're starting to get into blue zone resistivities, which in this case are going to be above 20 ohm meters, which means they fall into the zone of probably fresher water that are because of these higher resistivity, 20 to 75. If you go down to the next slide, which should be next page is 483, that's going to be the lower 180-foot aquifer, and we can see that in those same areas that we're looking at, red conductive material, which fall below, these colors are probably below 3 to even 2 ohm meters, and so they're very conductive, which are likely going to represent, because of our less than 3 ohm meters, they are going to represent the greater than 10,000 milligrams per liter material.
So is it fair to say, Dr. Ash, that the AEM studies, both the 2017 and the 2019, revealed these zones of high resistivity right in the CalAm site?
Very close to it, I would say, if not inside. You'd have to blow it up and look at it and see how close, but it's close. I'm not sure how close.
One final question, Dr. Ash. You referenced in your testimony today and in your submitted testimony that you used what you called a conservative cutoff that resulted in underestimating the amount of water in the lowest and highest TDS ranges. Can you explain a little more what you mean by that in terms of how the cutoff you chose resulted in that estimation, underestimation and overestimation?
So I think it may be best to go back to the summary presentation, and maybe it's about, take a look at the slides, but look at that histogram slide of the plot of water quality versus resistivities. And there you can see
so
the
let's
distribution.
get it before you answer. So we'll go to exhibit MCWD 108. And the histogram, I think, is slide 9. Tell us if that's what you're looking for, Dr. Ash.
That's my understanding, Mr.
You're correct. That's it. Yeah. So basically, you see that you see that black arrow under the 3 on the x-axis. That's where we picked to be the conservative estimate of greater than 10,000. You can see that orange range goes above 3. So we're near the bound, but we're not at the bound. So it's an approximation. The same thing at 20 ohm meters, the other black arrow. Our estimation is that above 20, we're in the less than 3,000 ohm meters TDS, or a milligram per liter range. But you still see that in MW9S, the shallowest green, we still had above 3,000 milligrams per liter. So we're right near the border. So we're kind of overestimating, underestimating what these of the different water qualities, but we're trying to make sure that we're giving some close approximation to what they probably are.
So Dr. Ash, I hate the word conservative because I never know what it means. It's sort of like it's conservative, depends on, I think what it normally means for technical people is it goes against the point they're trying to prove. But what do you mean by conservative here? I just don't understand that.
okay, conservative would be that, let's say that, like they take the three, the black arrow at 3, so less than 3 is supposed to be 10,000. But we could see that in these MPWS2 wells that we've got some chloride or TDS values at above 3, like maybe 3.25, 3.5. Okay, and so what we're saying is that we are basically maybe underestimating what the actual range is for what the true value of what's greater than 10,000 ohmmeter TDS. On the 20 side here, again, we're right, that 20 is right above the purple range, and between 3 ohmmeters and 20 millimeters, you've got a lot of overlap of different resistivities and different water qualities. And so conservative in this sense means that I don't want to say that, I want to say that everything over, 50 ohmmeters is going to be less than 1,000. Okay, that's ignoring water that could be at 25 ohmmeters. And so so I want to make sure that I'm trying to capture as much of a grouping as I can without being, missing too much of it.
I'm sorry, try to capture as much of what?
Try to capture as much of a population of data as I can without losing too much.
Okay.
So
Go ahead, Mr. Mount. Sorry I interrupted.
No, you're getting to the same point that I was trying to understand, Mr. Lilly. Dr. Ash, is perhaps a way to describe it that if you were to have chosen an ohmmeters threshold of say 18 as opposed to 20, that you would have captured more fresh water, but maybe would have also captured the potential more brackish water too. Is that accurate?
That's exactly accurate.
And on the same note, if you had chosen 22 ohmmeters as your threshold, you would have captured less fresh water, but maybe more brackish water too.
It's possible, yes. So we're trying to get approximations to work with. That's the goal.
Dr. Ash, thank you for your time. I have no further questions. Thank you, Mr. Lilly.
All right, thank you. Okay, before we take the break, let's try to do a little time scheduling. So, Mr. Osias, what's your, and I'm not going to hold it to you exactly, but can you give us a time estimate for your cross-examination of Dr. Ash?
Yes, it got a little longer, I apologize, because of the new information today, including some changes. So I'm going to estimate an hour and a half.
Okay. All right, let's go ahead. It's 2:30. Let's take a break until 2:45, and then we'll start your cross-examination. We should be able to finish that. I'll see whether I can get through my questions. I promised those of people who have trick-or-treaters involved, which may include my house, that we would finish by 5 for sure. So we won't go past 5, and if we need to, we can carry over into tomorrow morning. So let's remember, don't log out, but you can turn off your microphone and camera, and we'll be back at 2:45. Thank you.
Yeah, yeah. What? Oh, on the other, is it on here? Here? No, I got it. Is it here? Soon enough.
All right, there we go.
Okay. It's 2:45. Everybody's right on time. Mr. Osias, you may conduct your cross-examination of Dr. Ash, and of course, we'll screen share exhibits as you request.
Thank you. And I'm going to start. Oh, I'm sorry. I will say, so Dr. Ash knows, I'm first going to seek some clarification of some new stuff before I get into what I had previously prepared. But before I do that, I should introduce myself. So, Dr. Ash, I'm David Osias. I represent California American Water. Nice to meet you. Can you hear me okay? Because I'm going to need audible responses to my questions, not head nodding.
All right, sorry. Thank you. Nice meeting you too.
Okay. And we haven't met before, I don't think, have we?
I don't think so.
And you've never testified before, is that correct?
I've never testified as an expert witness, put it that way.
Oh, okay.
I'm sorry, you never testified what? I couldn't hear that.
I never testified as an expert witness before.
Okay, thank you.
I was
Go ahead.
involved in an Army Corps case, 15 years ago about some other site, but I was part of the project, wasn't really an expert on that one.
Okay.
Thank you for the clarification. Go ahead, Mr. Osias.
And have you ever been deposed?
Yes, I was deposed for that Army Corps.
So and that involved searching for buried ordnance or something like that. Is that correct?
That's correct.
Okay. AEM is actually good for that, right? Finding hidden explosives or metal objects or something.
Yes, that's correct.
Okay. I think I'm gonna do these sequential just because, although that isn't a strategic way to do it, it's the way my notes went, just for clarity of what you said. Can we go back to his slides and start with slide 3?
Okay, we'll post exhibit MCWD 108 and go to slide 3.
Thank you.
Go ahead.
Thank you. The orange line, was described as the seawater intrusion front, or is it just the one? Yeah, is that right? It's the seawater intrusion front in the 180-foot aquifer, correct?
Not quite. Look at the figure caption at the bottom there, about the fourth line. It says outlined in orange is the extent of saltwater intrusion in the uppermost aquifers, as mapped by Monterey County Water Resources. Okay, and then look at the legend just below the figure. So I don't know the exact answer to your question. Is it just up? It says 180-foot aquifer intrusion, but the legend says uppermost aquifers. So I'm not sure.
Did you prepare this picture?
No, I did not.
Who did?
This is from Ian Gottschalk at Stanford when he was a grad student.
I see. And the light blue line, I think you were asked a question about it by Mr. Lilly, and the dark blue line, and you said they reflected something from MCRWA, the agency. That's incorrect, isn't it?
I wouldn't disagree with you. I don't know where they came from.
Okay, thank you. In fact, there is no map that reflects the light blue line or dark blue line that you know of that came from the agency, correct?
That I know of, but I would imagine that Ian Gottschalk got them from somewhere.
I see. Did you review Mr. Gottschalk's testimony for this case?
I don't know if Mr. Gottschalk gave testimony. No one ever told me anything about that.
Okay, so I don't believe he has, but I was wondering whether I didn't find it. Okay, on the next slide, Next page, please.
Okay, so we'll go just for the record, we're on slide 5 now.
Oh, I'm sorry. So, okay, let me go to slide 3. I thought I was on slide 3. My bad.
Okay, we'll go back to slide 3. Go ahead.
So that was 3. Okay. So that's the one I asked about. So then slide 4 is what I want. I think we skipped.
Okay, we will now go to slide 4.
Thank you. And your answer about the orange line, the blue line, and the light blue line is the same as for slide 3, correct?
That's correct.
Okay. And your study area is the pink boundary, right?
I would say where you see the brown lines was our study area.
Okay, so
The brown flight lines. The brown flight lines.
well, that's where you
dashes there.
flew, but I'm looking at the pink line, which said region of interest. Who
Again,
came up with
that
that?
came from, I don't know.
Okay. And there are no flight lines over the ocean.
That's correct.
Do you know whether the dune sand aquifer extends under the ocean?
I don't know. I never looked.
And do you know whether the 180-foot aquifer extends under the ocean?
I think I've seen cross sections, but I don't know.
Okay. And you weren't asked by anyone to look for freshwater in either of those under the ocean, correct?
We were just asked to map the area and come up with possible estimates of water quality.
Well,
And
it's
we were not
in-
asked to fly over the ocean.
I'm sorry. Okay. So you were asked not to fly over the ocean?
We were asked, but this was a survey design that the Marina Coast Water District agreed to, and that's what we flew.
Okay.
If they wanted us to fly over the ocean, we would have, but they didn't ask, so we didn't.
Okay. So the pink boundary is not actually the focus of your study, even though a region of interest, it's actually only the area you flew over. Is that more correct?
The area we flew over is where you see the brown flight lines.
Okay, that's thank you. And that is the only region of interest that you studied.
That's correct.
Okay. So did you have something to add to that?
I was just going to say in 2019, that was extended south a little bit.
Yes, I remember that. Thank you. But not west.
No.
Okay. Can we go to, let me look at my notes, my slides, I mean. But I apologize, Mr. Lilly, but the slides aren't actually paginated anywhere that I can see. Is that right?
They are, at least when I printed them, there's a little number in the lower left-hand corner right outside the box of each slide.
Oh, when I printed them, that didn't happen. Sorry. So sometimes I just want to make sure I'm on the right page.
Okay, well, I'll help you. That's fine.
Okay, so I think it's slide 23. It's a table.
Okay, we'll go to slide 23 in exhibit MCWD 108. And it's table 4.4-6.
All right. And I believe, Dr. Ash, you said, because I didn't count, there were 24 rows in this table,
Correct.
and you've rejected 6 of them.
For the, when you
I didn't ask why. I just want to confirm that I heard it right. You rejected 6 of them?
I think your question is not complete.
Oh, I'm sorry. Okay. So in the column entitled cut, do you see that?
Yes.
They were cut from use for determining TDS. Is that correct?
Look up in the table caption and you'll see it says in the second line, the specific conductance presented earlier. In the cut column, a red X indicates data cut from the EC regression calculation and a blue X from the actual connectivity calculation.
Yes. And maybe I should have started with I'm a lawyer, and I could probably read that 5 times and still have the same question. Were they, as they were cut, as it states up above, for calculating those things that are stated up above, and therefore they were not used to produce the conclusion about EC or actual conductivity. Is that more correct then?
You're closer.
All right. TDS column, it says TDS CONC. I assume that's concentration.
Yes.
And salinity in mg per L, I assume that's also milligrams per liter of TDS, correct?
This is the data that was in the MPWSP water report, number 160. It was not clear. I could not find in their report descriptions of the different data columns. So I don't know exactly what goes into the salinity column.
They're relatively close, but not exact. But in terms of magnitude, is that a fair description?
Yes, I'd say so. Order of magnitude.
Yeah,
Those are the
well,
same.
okay. And how many of them that aren't cut include a TDS of less than 1,500? In any one column. You can use either column you want. Just tell us which one.
I'd say there's 1, 2, 3, 4, 5. Let's see. I count that in.
Not counting the ones that are cut.
Right. So there's 1, 2, 3, I'd say.
And the remainder are more than that, correct?
Now that was cut. Again, may I get clarification?
Yes.
When you're talking about cut, are you talking about the EC calculation or the actual conductivity calculation?
EC.
The EC?
Yes.
Then there's 3.
Okay, thank you. And how many that aren't cut for either reason are more than, say, 3,000?
Let's see. Nothing's cut. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Okay, so we don't have, again, I'm just a lawyer, so feel free to correct my vocabulary, but we don't have an even distribution of salinity samples in this table from high to low. Would that be fair to say?
I agree, and I make this point in the report.
Okay, so that's a yes. Thank you.
Yes, I agree.
Exhibit, you commented on Exhibit 4, page 12.
Do you want, we'll go ahead and post that
Yeah,
now?
we better, because I don't want to paraphrase. Thank you, Mr. Lilly.
Okay, we'll post exhibit MCWD4 and go to page 12, did you say?
Yes. I believe that's what he was asked about. And
I think you're there.
I think if you scroll down, it was near the bottom, and I think it was the sentence that ended sort of in salt water. Stop right there. So you're not a hydrologist, you said, as part of your answer to questions about this page. Do you remember that?
Yep.
And so flowing groundwater is a hydrology topic. Is that fair?
I would agree.
And mounding of groundwater is a hydrology topic. Would you agree?
I would agree.
Did you write this sentence?
No,
Who wrote it?
I imagine Ian Gottschalk wrote it, and he may have taken it from the Otten Environmental Report, 2017.
Do you know if he was sent your testimony to review before it was submitted?
No, I don't know.
Can you estimate how much of your testimony was written by someone else?
The testimony was derived from the 2017 reports and 2019 reports and other tech memos by Mr. Wilkins' group. And they put it together, and then they sent it to me for editing. They added in these questions and everything. But on the 2019 report, I wrote 98% of that. On the 2017 report, I wrote about maybe 2% of that.
Okay, so that was a lot of very useful information. So I hate to make you repeat, but I cannot take notes that fast. The questions were written by who in your testimony?
In the format, to create this format as a testimony, the questions were put together by Mr. Wilkins' group.
Okay, either him or somebody who works with him.
Yeah, I don't know who.
I see. And the 2017 report was written by you, and you said a very low percentage. I heard 2%, but is that correct?
I would estimate that, yes. I reviewed, it was written and developed, the whole process was written and developed by Stanford, Professor Knight and her student, Ian Gottschalk. I was sent to us for review, if it made sense.
I see. And then that flipped a little bit for 2019. Sounded like you did most of it or all of it.
In 2019, Stanford was not involved.
Was anyone other than you involved?
Me, myself, my team at AquaGeo Frameworks, yes.
Okay, how big is that team?
At the time, there were 3 of us.
Are you the senior member?
We're all equal members.
Who are the other 2?
One was named Jim Canyon. He was a hydrogeologist. And then the other is Jared Abraham, who's a geophysicist, and myself, geophysicist.
I see. And so can you estimate the percentage of the report written by each?
No. They talked about the 2017 report?
No, 2019.
2019, probably I was about 80% and they're about 10%.
Okay. And there's a missing 10%, which of course I have to ask you about. Sorry.
No, I'm 80. Jim was 10 and Jared was 10. That's
I'm sorry.
100.
Each of them were 10. My bad. Okay. Okay. Can we go to slide 8?
Okay, Exhibit MCWD 108, slide 8.
And again, I apologize. This is just the order they were presented, so I'm following.
That's fine.
All right. I'm looking at the column entitled Source. You see that? Okay. So I know you're nodding yes, and everybody watching knows you're nodding yes, but Mr. Lilly's
I
record
apologize.
will not know you're nodding yes.
I'm sorry.
Yeah, Dr. Ash, please try to say yes or no till we have it clear on the
sorry.
record.
So yes, I see the source column, yes.
Okay.
Thank you for reminding me.
No problem. Have you read Title 22, Article 16, State Water Resources Control Board, 2006?
No.
Did you find that source information yourself?
No.
Do you know where it came from?
Please clarify.
Yes.
It
Do
came
you know
from
what
State Control,
person?
State Water
What
Resource Control
person?
Board.
No. Yes. Thank you. That's actually maybe technically correct to my question, but not what I meant. So I'll clarify for you. do you know what person provided that citation as the source for the information in that row?
No,
And you haven't read it, you said, is that correct?
no, yes,
Yeah.
yes, I have not read it.
Okay, and in the second, well, I guess it's the third row because the first row has titles. So in the third row, there's an even more specific source reference. Title 22, Article 16, State Water Resources Control Board, 2006, SWRCB Resolution 88-63. Have you read that?
I took a look at it, just to glance at it, to see what it said.
And when did you do that?
I did that when I was working on the 2019 report.
Okay. And do you know the person, I'm sorry, are you the person who found this reference and chose to use it for that row?
No, I used the same table for 2019 as it was used for 2017.
And you know who was the source of that information for 2017?
Ian Gottschalk put it in the report. I don't know where he got it or who he talked to.
Okay. And you, I think you've referred to him twice now, but I'll just make sure I understood it. In 2017, he was a graduate student at Stanford.
Working under Professor Knight, Rosemary Knight.
A master's or PhD program?
PhD, I believe.
Okay.
And I don't know where he was in this program.
Thank you. And then the next row in the source column, it says US EPA 1988. Sort of a general site there. Did you read whatever US EPA 1988 means?
Well, I saw there was a reference at the bottom of the page, so I looked that up back in 2019.
Okay.
And I saw and I glanced through that.
Okay. So, and that was in, I think, the same time you did the resolution 88-63 review.
Correct.
Okay. And you said that was prior to your drafting the 2019, or was it prior to report, or was it prior to your study being done and determining what to evaluate?
A.
It was before you drafted your report.
No, this report was written by Stanford in 2017, 2018. Okay, so then I saw it in their report, and then I used the same table in the 2019 study.
Okay, but you said you glanced at it, and I was just trying to pin down in the chronology whether you glanced at it before you even undertook to start the 2019 field work, or just as part of writing up the report for the field work, that's when you glanced at it.
During the writing of the report, I wanted to see what these were. 2019 report.
Okay. That's been very helpful. We can take the slides down.
Okay,
Actually, I hope I don't regret that. I'll just repeat what we clarified before the break. Slide 24 through 29, wherever it says chloride means TDS, correct?
Correct.
And so let's put up your direct testimony, which is MCWD 4. We might as well start with page 1 just so you can see what I'm looking at.
okay, we've posted exhibit MCWD4.
And go ahead and scroll down there. Dr. Ash, you recognize this document?
Yes.
Can we go to page 72? Do you see question 63?
Yes.
And that question was written by counsel for MCWD, correct?
Correct.
And it uses
I
the word
guess, I don't know.
Oh, you don't know?
I don't know. I don't know who wrote it. It came from them, so I would imagine somebody wrote it there.
Okay. Your project report is not in Q&A style, correct?
No,
Okay. You see the word chloride in the question?
yes.
Is that an error?
No, in fact,
So the Southern Florida information was about chloride.
that's why I think in terms of chloride, because I work in that study still.
Okay. And then question 6, and then there's a discussion with that Fitterman and Prinos reference you made, I think, in your testimony. That's a chloride study, correct?
Correct.
Okay. Again, I'm just trying to figure out, given what happened with the slides, if we can scroll down farther. And question 64 was about creating profiles for the report. Do you see that?
Yes.
And it's about chloride concentration profiles. Should that be TDS?
Yes.
And so if you look at can we just scroll slowly? You can see that your answer to 64 runs from line 13 all the way to the end of the page, and there are innumerable references to chloride and chloride concentration, including references to calculations by Fitterman and Prinos. Are all those supposed to be TDS or only some of them?
All TDS.
Except for the reference to Fitterman and Prinos, correct?
It's in 63, question 63. Yes.
Well, I'm sorry, do you see line 15? Actually, go ahead and start on line 13 and look at the answer, the first sentence.
Yes.
You've read that yourself?
Yes.
Okay. So you're going to use your AEM study and chloride concentrations as calculated by Fitterman and Prinos to create profiles of TDS concentrations. Is that correct?
Yes. There's between line 14 initially between 2019 AM inverted resistivity and chloride and TDS concentration distribution as calculated by the Fitterman and Prinos process. That's probably a better word than relations. And then between 2017 and 2019 results.
I'm sorry. I heard you use the phrase TDS when reading lines 14 to 17, but I don't see those words in there. Where did you see them?
Are you asking me if on line 14 it should say resistivities and TDS concentration distribution? Is that your question?
No, I was trying to understand your answer, but that's a fine question.
Let's just tell us, Dr. Ash, on line, it's 14 and a half. Should chloride be TDS or is chloride correct?
TDS is what it should be.
Okay.
The calculations that were made for the 2019 report were all in the TDS regression based on the AEM and MWSP water resistivity and TDS measurements.
Okay.
But it says on line 15 and a half, as calculated per the Fitterman and Prinos relationships, which is a chloride relationship. Isn't that correct?
That is the exact Fitterman and Prinos 2011 relation is discussing chloride in Southern Florida. I used their process of regressing, correlating between rho AEM and rho W is the first step, getting a regression relationship. And the second step is between rho W, water resistivity, and TDS concentrations. That is their Fitterman Prinos relation. You can call it relation or process. I did not actually use the exact Fitterman and Prinos equations. I used the local area developed equations to convert the 2019 AM inverted resistivities to TDS concentration distribution, and then comparing the 2017 and 2019 results.
Okay, so rather than, as it reads, as calculated per the Fitterman and Prinos relations, it should read something as illustrated or based on or something like that. Is that more accurate?
Yeah, I would call Fitterman and Prinos process.
Thank you. Did you submit the Fitterman and Prinos report as an exhibit?
Possibly. I think maybe. I think because I was asked to, for the deposition, I was asked to provide all references and everything, and I think I did that, but I'm not sure.
Okay, and you actually weren't deposed, correct?
That's correct.
Okay, and so if we scroll down, the paragraph that starts at 17 and a half and goes all the way to 27 and a half, every word of chloride or chloride concentration phrase should refer to TDS or TDS concentration, correct?
Correct. I apologize.
Okay, and then on page 7, I'm sorry, the next page. Stop right there. So chloride concentration at the top in the rainbow display. Is that supposed to be TDS?
Yes.
And what's the relevance of 1 to 250 TDS?
If we are able to estimate, if we have resistivity such that we get TDS concentrations between 1 and 250, there will be a color range for it.
And so it has nothing to do with the fact that 250 milligrams per liter is the recommended chloride maximum for chloride in drinking water. Has no relationship to that.
No relationship at all.
Just a
I
coincidence.
just use it to break up the color scheme.
I see. And you use 250 to 1000 here, which is not a TDS reference you've used anywhere else, correct?
Correct.
You've used 0 to 1000 somewhere, I think. Is that correct?
In the TDS table by the State Water Board, yes.
Okay. And therefore, starting on line 9 with the heading and to the bottom of this page, every reference to chloride is a mistake.
That's correct.
Can we scroll down and see how many? And these figures at the bottom, can we go a little farther? Using the color scale, that's TDS, not chloride. Is that correct?
That's correct.
So you found TDS of 250 to 1000 in that bottom figure towards the left side in 2019. Is that what that means?
That's what that means. We had resistivities that correlated to that value of TDS concentration.
Okay. And the next page. And the top paragraph, those chlorides are not chlorides either, right?
That's correct. Should be TDS concentration.
And if we scroll down, and we repeat the chloride concentration color scheme, but that's TDS.
Correct.
Correct. And the title, question 65. So let me pause for a minute. Did you have draft testimony without the questions first, and then the questions were inserted?
I think there may have been a version of that, and then they inserted questions, but it was a mixed bag, I'd say.
Okay, and do you believe the counsel for the district reviewed the contents of your draft testimony and saw all the references to chloride and put them in the questions.
That's correct.
You
Based on what they read.
You didn't tell them you meant TDS and they just typed chloride.
No.
Okay. And then this is similar to, I think, a slide we saw on in your summary. Is that correct?
I think so. I'm not sure.
Okay.
Similar.
And then on the next page, 75. Everything that says chloride doesn't mean chloride, correct?
Correct.
All the way to the bottom of the page. All should be TDS, correct?
Correct.
And page 76. See line 4?
Yep.
Chloride concentration should be TDS, correct?
Correct.
Okay. And you didn't anywhere point out that there was water that you found of 250 to 1000 TDS, did you?
Please clarify.
Yes, you identified water that was less than 3000 TDS, but we're talking pretty high quality water. If it's all the way down to 250 TDS, you would think that would be worth mentioning, but you didn't mention it anywhere, did you?
That's not correct. I did.
Okay, where did you mention that there was 250 TDS water?
Can we go back to the 108 to the slide?
Okay, we can put up exhibit MCWD 108 and tell us what slide you'd like us to scroll to.
And go to about slide maybe 20, 28, maybe 27, 28.
Okay, we'll start at 27 and then tell us if we need to scroll forward.
Okay, this is fine here. So this slide shows resistivity less than 75 millimeters, which means it is in saturated material, and the color scheme is a plot for both 2017 and 2019 of the 1 to 250 and the 250 to 1000 group, and then the 10 to 19 and the 19 to 40K groups. Okay, and then.
Pardon me, I did not mean to interrupt.
Okay, then the next slide shows similar. Next slide, 28. And here's a view of it. You can see that the dark blue is the 1 to 250. The kind of bluish gray is the 250 to 1K, and then you see the red and the browns are the greater than 10K and greater than 19K. All right.
Stay on this page,
And
if you wouldn't mind. Sorry, did you have somewhere else you wanted to show me? I apologize.
no, that's fine. Go ahead.
Okay. And I forgot the phrase you used. I don't know if it's a side view or an edge view or an edge cut, but this is sort of showing a vertical rendering. I mean, with a 3D rendering, maybe that's better. Is that correct?
It's a voxel rendering.
Yeah.
And we are looking to the north, pretty much.
Okay. And you warned in your testimony that we should be wary, although you said chloride concentrations, apparently you meant TDS, that we should be wary of TDS concentrations at the top, where it could be dry material. And we see a lot of the Kansas City Royals blue at the top of this rendering. Not all of it, but a lot of it is on the top of this 3D rendering. Is that correct?
No, this is less than 75, so this is this is saturated material. I think what you're referencing is another slide. Maybe you want to go up 2 slides, looks like, maybe 26.
Wait. Stay on that slide. I
Okay,
see
this
the
slide does
heading.
not show unsaturated material. This slide only shows saturated material. The blue you're seeing is the saturated material of resistivities less than 75 ohmmeters.
Okay, so based on the resistivity, you've determined that's water, not land. Is that what your conclusion is?
That's correct. That's
Okay.
our estimation, yes.
I see. Okay. So during the lunch break, we can take this slide down. Those pages I at least had you look at all reference chloride. I don't know that I've cut them all. But if there's any other pages in your report that use chloride instead of TDS, I should translate it to TDS. Is that correct?
That's correct, except for the discussion that's talking about Southern Florida with Fitterman.
Okay. And so, Mr. Lilly, I have other areas to investigate, but I had a whole lot of preparation based on chloride. So
Okay.
I won't ask those, obviously. And perhaps when we have the other experts up, we could bring Dr. Ash back, at least for some of that.
Well, yeah, maybe. I'm not going to just say yes. You're going to have to demonstrate to me why you think you need to bring him back. So I'm not saying yes, and I'm not saying no. I'm saying if you want to do that, you need to make some kind of an offer of proof, and I'll give the MCWD attorneys an opportunity to respond to that before I rule on that.
Okay.
I mean, today is your opportunity to cross-examine Dr. Ash.
Yes, although I have both summary slides and a report with numerous mislabeling to be.
I understand that. And if you get to a point where you say you want to regroup and come back tomorrow to finish your questioning, I will allow that.
Oh, okay.
Because I do understand this. I mean, I'm not pointing any fingers or anything, but I understand from your point of view, this has been a little hard to follow. So go ahead and we'll see where we are.
Okay. No, I think I'm done for now with the trying to find where chloride was.
Okay. So do you have other lines of questioning?
I do. I will go back to what I had prepared before.
Okay. Why don't you go ahead?
And so can we go ahead to MCWD? Hang on, I got to move my notes now. MCWD 4, page 4.
Okay.
So this is the first page of the contents of your direct testimony, correct, Dr. Ash?
Correct.
Okay. Are you aware that a lawsuit was brought by the city of Marina and the Marina Coast Water District against Cal-Am?
What suit are you referring to? Please clarify.
I'm sorry,
Please
did you ask me
clarify
what,
which suit?
which
Please
suit?
clarify which suit?
Oh.
Yeah, I'm not.
Are there more than one?
I don't know.
Oh, okay. Do you know why we're here in front of the state board?
There's a disagreement between MCWD and the city of Marina and Cal-Am.
Okay. So page 4 starts with question 1. Would you now go to page 86?
Okay, we'll move to page 86.
And so the final question in your direct testimony is question 76. Do you see that?
I see that.
So is it fair to say that 76 questions were answered in your direct testimony?
If that's what it shows, yes.
Okay, and then you submitted rebuttal testimony, which is MCWD Exhibit 91. Can we show that for a minute?
We can pull that up. Exhibit MCWD 91. And tell us what page you'd like to scroll to on
Page
this.
one, page one.
Okay, page 1 is the title page.
Oh, I'm sorry. Page 2.
Okay, we'll move to page 2.
That's fine. And Dr. Ash, you recognize this as the start of your rebuttal testimony, correct?
Correct.
And it starts with question 1, correct?
Looks that way.
Okay, and can we go to page 13? And question 23 is the last question of your rebuttal testimony, correct?
Looks that way.
So you answered combined 99 questions, correct?
Yes.
Now, were you aware that the judge in the case, one of the cases maybe in your mind, but at least in one lawsuit pending in Monterey County, referred 8 questions with subparts for the state board to answer, and that's what this administrative hearing is about. Did you know that?
Did you say that again? I lost you.
Were
So
you
that 8
aware
parts?
that the court in Monterey County Superior Court referred 8 questions with subparts to the State Water Resources Control Board to be answered, and that's what this hearing is about? Were you aware of that?
No.
And none of those questions are among the 99 questions that you answered. Isn't that correct?
Well, wait, I think
Objection.
you have to do a foundation, Mr. Osias. He said he was not aware of the 8 questions, so unless he knows what the 8 questions are, it's not fair to ask him if any of his or overlap with that. So I think the first question is to ask him if he knows what questions the court asked the State Water Board.
Well, I can show him, I guess. So the easiest place to show him is probably.
I think we can save some time here. Dr. Ash, are you aware of, or do you know what questions the court asked the State Water Board?
No, I do not.
So I don't know, Mr. Osias, is this really going to get us anywhere? I mean, I think your point is pretty clear here.
Well, I'll make an offer of proof and then we can move on that not one of the 99 questions is a question or subpart from the court.
Let's see, Mr. Wilkins, are you willing to agree that none of these 99 questions equals any of the court's questions?
I would agree. We never asked a single of the exact questions. Obviously, it's our opinion his testimony bears on a number of the questions, but I would agree none of the questions are the questions that the court asked.
Okay, I think that point's pretty clear, Mr. Osias. So we could go through and look at them one by one, but let's move on. I think you've made your point.
Thank you. Dr. Ash, are you an owner or an employee of Aqua Geo Framework?
I am a member of a limited liability partnership.
Okay. And can I call it AGF? I see that referenced in the materials.
Yes, AGF, Aqua Geo Frameworks.
Thank you. And is AGF the source of your income?
Yes.
Can we pull up MCWD Exhibit 35?
Okay. We will get Exhibit MCWD 35. I don't think we've seen that before. today anyway.
No, not today. And if we could go to the next page so that the witness might recognize this document. Let's stop right there. Whoop, scroll down a little bit. So do you recognize this document?
Yes,
Okay, this is an article published in Geophysics, volume 85, number 4, in July to August 2020, correct?
correct.
And there are 5 authors listed, correct?
Correct.
And you're number 3, is that correct? If you read from the left.
Correct.
And they're not listed alphabetic, correct?
Nope.
And no, meaning you agree, they're not alphabetic.
I agree. They're not in alphabetical order. Yes.
Okay. So what sequence are they in?
Ian Gottschalk was Rosemary Knight's graduate student. And then there's me, and then my other 2 partners, Jared Abraham and James Canyon.
Okay, so that's helpful to know who they are, but why
Different
are they in the?
professors.
Wait,
Why are
wait.
they-
I think he's going to answer your question.
Oh,
Go ahead,
okay.
Dr. Ash.
Different professors from different universities have a different style of how they publish papers with their grad students. Some professors will put their own name first and then the grad student. Other professors will put the student first and then their own name. In this case, it's a student first and then the professor.
Was this article primarily written by the student?
We received it from Stanford. So between the student and Professor Knight, it was written. You'd have to ask her and him who wrote it.
And you wouldn't just put your name on an article that was going to be published in a journal without careful review of the article, correct?
Correct.
And I assume Geophysics is a fairly prestigious journal? Yes?
Yes.
Okay. And this is a fairly recent, I mean, with 2 years old only article, correct?
Yep.
And can we look at page, well, actually, what was there funding connected to the publication of this article?
Not to AGF. I don't know about Stanford.
Okay, can we turn to page 14? I'm hoping.
Okay, we have PDF numbers at the bottom. So let's turn to 14 and see whether that's where you want to. Wait,
It is.
that's
I've
the
tried to
last
do,
page. Okay, go
yes,
ahead.
I've tried to do PDFs.
Go
And so
ahead.
If it's
We're
only
on
when I
page
make a
14.
mistake. And can you see under acknowledgement? There's a sentence, and can you tell me what was the source of funds for this project?
Which sentence do you want?
The very first sentence under acknowledgements?
Funding for this project was provided by Marina Coast Water District.
So they were the source of funds?
Well, wait.
Funding for the-
You've got to split that up, Mr. Osias, because he's already made a distinction between funding to Stanford and funding to AGF. So ask your 2 parts of your question as to whether each one of those received funding from MCWD.
Fair enough. Well, I think he said this article generated no funding to AGF. Isn't that what you said, Dr. Ash?
That's correct.
So there's a sentence that starts with funding, and then there's a second sentence with additional funding. All that funding went to Stanford. Is that correct?
That's correct.
Okay. And that's where,
I only read what you read.
okay, you don't know anything contrary.
No, I don't know anything contrary.
Okay. And that's where you said Gottschalk and Knight are located. Correct.
Correct.
Okay. we're going to come back to this in a minute. So we can just leave it here while I ask a question that I don't think needs a document.
Okay, well, Miss Mullen can take it down and then she's got a
Okay.
way to open
Okay.
it again rapidly. Believe me, she knows not to close the file
All right.
during one of these proceedings. Go ahead.
So, Dr. Ash, I'm sorry, let me stop. A monitoring well serves what purpose?
Monitor.
Does it pump water out?
I would imagine it would depend on the well and who's doing it, why they're doing it.
Okay, and could you contrast a production well to a monitoring well? Could you explain the difference between the two, or do you not know?
I have an idea that production wells are meant to pump a lot of water out, and monitoring is to monitor in a given zone what's going on. That's my basic understanding.
So if I ask you a question about production wells, you would understand that phrase is mainly what I was trying to understand.
Possibly I may understand, I don't know.
Okay. And you're familiar with the area that you studied, correct?
To some degree.
So are you aware that there are no production wells screened in the Perch Mounded or A aquifer?
I don't know.
You don't know one way or the other.
I don't know one way or the other.
Okay. And would you agree that there are no production wells screened in the Dune Sand aquifer?
I don't know one way or the other.
Did you seek production well data for any TDS data purposes?
We asked for any available well data that was available.
And had there
We
been
didn't say we wanted.
Go
I
ahead,
was gonna say, we
Dr.
didn't
S.
say-
Answer your question. Mr. Size, let him answer.
We did not specify. We want production wells only. We want monitoring wells only. That was never asked. It was just the wells that were provided to Ian Gottschalk. And then in 2019, we were provided 84, I think mostly the zoology wells from Fort Ord. But there was never any mention of production or anything like that.
So you don't know if the Perched Mounded A aquifer is a source of drinking water for anyone, correct?
Correct.
And you don't know if the Dune Sand aquifer is a source of drinking water for anyone, correct?
Correct.
Can we then go back to Exhibit 35, page 6?
Okay.
And can I get a time check, Mr. Lilly?
Yes, sure. It's 3:45. You started at 2:45. You've been going for 1 hour.
Okay, I may be another 45 instead of 30. I apologize. It
Okay,
took
well,
longer to get through the clarifying, but
No, you're being relatively efficient. So keep going.
thank you. Can we scroll down? There's a paragraph that the first three words are in figure 4. Should
Wait. I'm sorry. I can only single task here.
Oh.
And I want to state this for the record and myself. We have exhibit MCWD 35 up. And what page are we on?
6.
Okay, PDF page 6. Go ahead. Thank you. Excuse me.
Yes, and you can see the last paragraph on the left starts with in figure 4. Do you see that paragraph, Dr. Ash?
Yes.
And if you read down 4 lines, you'll see a phrase after a comma, based on public drinking water standards. Do you see that phrase?
Yep.
What does public drinking water standards mean to you as an author of this article?
I have no idea. Only table I'm familiar with is one from State Water Resources Board and the EPA. I have no idea what public drinking water standards are. This was written by Ian Gottschalk and Rosemary Knight at Stanford. I have no idea what they're referring to. The next line, though, says TDS less than 3,000 corresponds to the source of drinking water. State Water Resources Control Board, 2006.
Do you agree with that?
That's what the State Water Resources Control Board, 2006. It says public drinking water standards, and then it says, TDS less than 3,000 milligrams corresponds to a source of drinking water. And I agree with that. That's what the State Water Resources Control Board, 2006 says.
No, that's not my question. My question is describing TDS of less than 3,000 milligrams per liter as a source of drinking water with a citation to that State Water Resources Control Board 2006 document. Do you agree that that's a true statement?
Which statement exactly are you referring to?
The sentence in your article. You can read to yourself again if you want the whole sentence. I'm asking whether you agree with it or disagree with it.
I'm asking which part of that sentence are you asking about?
You can, the part that starts with divided into 3 ranges of TDS concentration. Do you see that?
Yep.
And it goes on to say, based on public drinking water standards, correct?
Correct, I see that.
And then it's the language you read to me. Do you see that?
Yep, that's what you're talking TDS and 3,000 State
Right.
Water Resources
So-
Control Board, right?
Yes. So your name is on this article. And my question is, as an author, do you believe that's a true statement?
I believe TDS less than 3,000 corresponds to source of drinking water. I believe that 3,000 less than TDS less than 10,000 corresponds to water potential beneficial use by the EPA. And I agree that TDS greater than 10,000 milligrams per liter corresponds to water of limited beneficial use per the EPA, which
And
they
you
refer
believe-
to as saltwater.
I'm sorry, when you pause, I start because I'm trying to hurry, but I shouldn't do that. And I will stop from now on, I hope. So have you finished your answer?
Yes,
So you believe the references, both to TDS and the documents that provide the source, are the definition of public drinking water standards, correct?
no. I don't know what the public drinking water standards are.
So without knowing that, you were still okay putting your name on this, is that correct?
I am, because I assume that Ian Gottschalk and Rosemary Knight had looked that up, and then they probably know what public drinking water standards are. My reference is looking at what is the actual data. TDS less than 3,000, 3,000 less than TDS less than 10,000, TDS greater than 10,000. That's what I'm looking at. Are those correct or not?
Okay, can we go back to your testimony then? Exhibit MCWD, Exhibit 4, page 10. And can you scroll down? So we can see the table. Actually, stop right, well, go back up to question 19 for just a sec. Thank you. So this is your direct testimony, correct, Dr. Ash?
That's correct.
In line 11, you use the pronoun we. Is there some other author of this that's defining this other than you?
Yes, this came from the report of Stanford.
I'm sorry.
This paragraph, in fact, this paragraph is a direct quote, I imagine, from Stanford, just above the table in the report.
So you're saying
As I
under
said,
oath, what's contained in this paragraph and the source document is from the Stanford report, correct?
That's correct.
Okay. And then now you can see the rest of the table. Just so we look at it. Can we scroll down a little bit? And you're familiar with this table, correct?
Yes,
This was in your summary slides today, correct?
Correct. The whole section was.
Yes, but it's a little different than the table in the article because this one has an intermediate row that was missing from that article, correct?
Correct.
Okay. Can we put up CalAm Exhibit 101?
Okay, let's post Exhibit CalAm 101.
You understand, Dr. Ash, that drinking water is highly regulated, correct?
Yes.
And that's why there are statutory, both state and federal rules regulating it, correct?
Correct.
And among those rules, are you aware that an annual report on whether you comply with those rules is required?
Yes.
Okay, and this is a MCWD Consumer Confidence Report dated 2021, correct?
I see 2021 on it.
Do you have any reason to believe that it's not from 2021?
No, I have no idea. I just see 2021 on it.
Okay, and in these reports, if you look at under the heading in the middle where it says MCWD Consumer Confidence Report,
Yes.
it says it's a 2021 report, correct?
Yep.
And the second sentence says what the purpose of the report is. Do you see that?
Wait a second. I'm not sure. Where are you reading now? Are
Okay,
you
so
in the
the top?
text below MCWD Consumer Confidence Report?
Yes, Mr. Lilly. And I'll
Okay.
direct the witness to the specific sentence. I apologize. I was going too fast. Do you see where it says this annual water quality report includes information about where your water comes from, what it contains, and how it compares to drinking water standards? Do you see that?
Yes.
Okay. So that's almost the word public drinking water standards, but the word public's not there, but it's going to report on drinking water standards. That's at least what it says it's going to do. Do you see that?
Yes.
He already said he said it, so why don't you move on?
And in 2021, in the second paragraph under the next heading, it identifies where the water comes from wells of MCWD. Do you see that? There's two in the deep supply.
I see two deep supply wells, 10 and 11, located in
Yeah.
Central Marina.
Okay. And are you familiar with those wells?
No,
Okay.
I think they were in their data set, but I'm not familiar with them.
Okay. And then the next sentence says the remaining 5 supply wells, 29, 30, 31, 34, and Watkins Glen. Do you see that sentence?
Watkins Gate, yes.
Oh, yes. Thank you. Watkins Gate. And it says where they get their groundwater collectively, correct?
Yes, I see that.
Okay. So on the next page, under water quality on the left, the very first sentence says the district diligently monitors water quality for drinking water and once again is proud to report that your tap water meets California and federal drinking water standards. Do you see that?
Yes.
So rather than saying public drinking water standards, it uses the state and federal. You see that?
I don't know if they place public, but I see California and federal.
Do you believe there are any other drinking water standards applicable to Marina Coast Water District?
I don't know about drinking water standards, so I wouldn't know.
Oh.
Huh.
Okay.
Mr. Osias, please try not to make sounds like that. That could be interpreted as being condescending. So please just ask your questions.
So I don't think I was the source of the, I'm sorry.
Oh, I'm sorry.
Yeah.
If it wasn't from you, then I apologize for accusing you of that. I heard it from somebody, and whoever it was, try to avoid saying that. We try to just have questions and answers in this proceeding.
Yeah, I agree with your comment, Mr. Lilly.
Okay, go ahead. Excuse me, if I'm falsely accusing you of something.
So can we go to page 4?
Okay, let's go to page 4.
And this page is at the top says groundwater supply wells water quality. Do you see that?
Yes,
And then a heading in green is primary drinking water standards.
yes,
And then there's a heading, I don't know, not quite halfway down the page, secondary drinking water standards. Do you see that?
yes,
And you see that there is a standard for chloride.
yes.
And what does it say? I'm sorry. Do you see the column that has the 3 letters MCL?
I see the column MCL, yes.
Okay. And MCL stands for maximum contaminant level, but it says that earlier in the report. Do you need me to go back to show you that?
Concentration,
I'm sorry,
concentration
maximum
level?
concentration level. My bad. Yes. You knew that, correct?
I'm guessing.
Okay. Do you see the row that has chloride?
Yes,
And what is the maximum for chloride?
500 milligrams per liter.
And you'll see there's also a column that says major sources in drinking water. You see that column?
On the right, yes.
Yes. Okay. And for the district, the major sources of chloride are runoff, leaching from natural deposits, and seawater influence, correct?
Right.
Now, maybe 6 rows down or 1 row up from the bottom of that section, you'll see total dissolved solids.
Yes,
You see that?
yes.
And the maximum allowed under California and federal drinking water standards is what?
1,000 milligrams per liter.
Now you see there's a column that says range low to high.
Yes,
And for total dissolved solids, what is that range?
it says 286 to 580.
And then you see a column that says violation.
Correct, yes.
And it says no, not a violation. Is that how you would read that?
Yes,
Okay, and then it also, under major sources in drinking water, it says runoff / leaching from natural deposits. Do you see that?
yes.
Now, do you believe this water quality standard would govern the ability to deliver groundwater with a TDS of 3,000 milligrams per liter if it wasn't first desalinated?
Objection calls for a legal conclusion beyond the scope of his testimony, and witness has never even seen this document before, as he said.
Yeah, Mr. Osias, I think you can make these points with legal arguments, but I think you've now gone too far for asking this witness. There's no foundation for his knowledge of this, and you're asking him questions that are pretty darn clearly outside of his area of expertise. So I'm going to sustain that objection.
All right, well, I will, just for the record, note that his report, his testimony, when I say his report, I mean his technical 2019 report, his direct testimony, his rebuttal testimony, his 2017 technical report, all describe public drinking water standards or euphemisms for it as including TDS up to 3,000. And at least his testimony is under oath, and his reports are authored by him. And to ask him whether he thinks the limit actually should be 1,000 rather than 3,000, I think is an appropriate question.
Oh, okay. Well, I don't think that was what your prior question was. I think you could ask that question, but I will say somewhere along the line, I think you can probably make this point a lot better if you have some other witness authenticate this exhibit, which presumably Mr. Schwertzinger could readily.
Right.
And then you can make your argument. But I guess I will allow you to ask a question along the lines of, do you think? So try that, but not do you think that this would be a violation? But I think your question was, do you think the standard should be 1,000 or 3,000? Was that what you were asking?
I was asking whether a drinking water source that, I'll ask the question, is that okay, rather than
Go
respond?
ahead and ask the question and we'll see what Mr. Wilkins says.
Okay, so Dr. Ash, do you think a groundwater source of 3,000 TDS meets the standard for drinking water?
And I guess the objection is that there are a lot of standards. He said he's not familiar with them, other than the ones that are in his report. And so asking him about them is beyond the scope. And I'm not quite sure where he's going with this, but yeah.
Okay, I'm going to overrule the objection about being beyond the scope because the State Water Board rules in Government Code 11513 very clearly say cross-X is not limited to the scope of direct. But I'm going to sustain the objection on my own motion. I just think this really goes beyond his area of expertise, Mr. Osias. Way beyond his area of expertise. So unless you can tie this back to what he has testified he knows about, which, is clearly geophysics and related topics rather than compliance with drinking water standards, I'm not going to allow the questions. So try, if you want to try, otherwise I think you need to move on. I mean, these are really things that they're either addressed better through legal argument, or potentially you can ask Mr. Schwertzinger, and I'll give you an opportunity to call him back if you think you need to, but he's the district manager and presumably knows a lot more about what the district needs to do to comply with drinking water standards. So I just don't think it's fair to ask Dr. Ash these questions.
Can we go to MCWD Exhibit 4, page 26? And can we look at line 25?
Okay.
Do you see the phrase freshwater saturated sediments?
Okay, why don't you read just so I can get up to speed, why don't you read out loud, Mr. Osias, starting slowly, starting on line 23, so we have the whole sentence.
Okay, I'm starting now. Quote,
Go ahead.
Having mapped the water table, we then proceeded with our analysis of the data, interpreting as described in the next section, that was in parentheses, regions where the resistivity values were the highest as being freshwater saturated sediments, and regions with the lowest resistivity values as being saltwater saturated sediments. End of the sentence.
Okay, now ask your question.
Dr. Ash, what does freshwater mean in that sentence?
It means where resistivity values were the highest.
It means what? I'm sorry, I didn't hear you.
It says where the resistivity values were the highest.
It has no other meaning other than that, correct?
To me, that's correct.
It has no TDS range associated with it, correct?
I don't believe at this point whether it does or not. I don't know. Just resistivity values were the highest. It says he writes as being freshwater saturated sediments.
Mr. Lilly, in the interest of time, I had MCWD Consumer Confidence Report for 5 years total. 2017, 2018, 2019, 2020, and 21. And I'll make an offer of proof that each are organized in the same fashion. Each specify the maximum chloride and TDS, reports the range of those from MCWD wells, whether they're in violation, and the sources. And rather than ask this witness the same set of questions, I presume he'd give the same answers. I assume we limit it to the ones you allowed. And if you'll accept the offer of proof, I won't do that.
Are those exhibits, excuse me, are those reports labeled as
Yes,
CalAm
they are.
exhibits?
Yeah, so year 2020 is CalAm 99. 2019 is CalAm 96. 2018 is CalAm 95. And 2017 is CalAm 94.
Okay, so here's what I suggest you do. I think the answer is based on Mr. Wilkins' objection and my ruling. It's not appropriate to ask this witness questions about those exhibits. The line of questioning may be relevant to this hearing. It's just that this witness is just clearly not qualified to give the answers. So I'm going to allow you some flexibility, and we'll carry over into tomorrow as necessary. And if you want to call back Mr. Schwertzinger and ask him questions about that, that's fine. But that's just so clearly within his area of expertise and not within Dr. Ash's expertise that I'd like to do it that way. I didn't have them on a panel because I didn't think their testimony was going to overlap. Maybe I should have. But anyway, that's how I'm going to proceed. I think that will allow you to, number one, authenticate the documents, which would take about 2 questions, maybe 5, one for each document, and then potentially ask 1 or 2 questions of Mr. Schwertzinger. So that's my ruling on that.
Thank you. Can we go to MCWD Exhibit 29?
Okay, let's post exhibit MCWD 29. Go ahead, we have it posted.
And if we could go to page 2 so we can see what it is. Stop right there. Dr. Ash, you recognize this, this document?
Yes. Yes.
This is your final report from 2019, is that correct?
Correct.
And you had an earlier one, and then you had at least a piece of participation in the 2017 one, but this is the most current, correct?
Yes.
Okay.
Slide down a little bit, please. Scroll
Yes.
down a little bit. Keep going. I want to see the date. Okay.
Does that change your answer?
No, just want to make sure that was the final version.
Okay. And you confirm this is your most recent work product?
Please clarify the question.
This is your most recent report.
This is the 2019 final report.
Can we go to page 158? And we need to scroll down. Maybe we need to shrink it a little bit so we can see both the top label and the figures. Just one
Okay,
there.
we can
Perfect.
do, is that good? Okay, good.
That's good. Do you recognize this page?
Yes.
You prepared it?
Yes.
Okay. Well, let's go through what's on it. I'm sorry, I think you need to scroll down just one tick.
Okay, if you want to, we
No,
can zoom.
that's good. That's good. We're
Okay.
okay. Thank you.
Okay, go ahead.
So to walk through it for a minute, because you have many pages that are similar layout. Is that correct, Dr. Ash?
Yes.
Okay, so the Cal-M site is a red rectangle on the coast. About this,
Yes.
not quite, a little above the center on the left, correct?
Yes.
And there's a yellow line with a label that says Dune Sand Freshwater Capture Zone. Do you see that?
Yes.
And that yellow line is not your work product, correct?
Correct.
And that label is not your work product, correct?
Correct.
There's a title on the left figure, or I guess figure or map, and a title on the right, and they're identical except for the left is 2017 and the right is 2019, correct?
Correct.
And they're side by side comparable analysis based on the work of those two different years. Is that a fair description?
Based on, yeah, I think, please clarify the question. I'm not sure. You
Yeah.
said based on the work. I'm not sure what that means
Based-
exactly.
The 2017 titled figure is from the 2017 report, and the 2019 titled figure is from the 2019 report. Is that correct?
No.
All right. Will
Good.
you explain to us what's incorrect?
The 2017 figure is from the 2017 data set, and the 2019 figure is from the 2019 data set.
Okay, so I used the word report and I should have used data set. Is that right?
Yes.
Okay, thank you for that correction. And then you'll see in the title the word thickness. You see that?
Yes.
Thank you. And then there's a scale for the thickness, maybe 25% up from the bottom, in a sort of a pale blue to deeper blue sequence. Do you see that?
I think it's actually white to dark blue, but yes.
Okay. And at the left margin, it's depicting a thickness of 2 meters, correct?
Yes.
Is that about 6 feet?
Yes.
And then at its maximum, it's showing a thickness of 80 meters. Is that correct?
Yes.
And since I know a meter is not exactly 3 feet, what is that about, if you know?
In feet.
Yes, thank you, Mr. Louis. That's what I meant.
About 262 feet.
Okay. And so then this is also has a legend, or maybe legend is the wrong word, but has a description at the bottom next to the figure 4-94. Do you see that?
Yes.
And it's a comparison of the TDS distribution, excuse me, and thickness for the TDS range of less than 500 milligrams per liter in the upper 180-foot aquifer from the 2017 left image and 2019 right image, AEM surveys within the bounds of the 2017 AEM survey. Is that a fair description of what these are?
Yes.
What does thickness mean?
Please clarify.
The word thickness, you use it in the title, you have a scale for it, and it's in the caption at the bottom. I want to know what the word means, thickness.
It means how thick something is.
So it would have a vertical height component,
Yes.
and you are identifying what that height component is by color, correct?
Correct.
And you're identifying where it's located on a map by placement of rectangles or blobs, correct?
Yes.
Why did you analyze less than 500 milligrams per liter?
The truth is, I wanted to minimize the number of figures. There were so many figures, ranges I could use, I just chose kind of a few different ranges to get an idea.
I see. Now, when we were looking at your summary slides and your testimony with respect to the mistakenly labeled chloride, you had a color that was less than 250. Do you remember that?
Yes.
And you didn't do one of these figures for less than 250, correct?
No.
Okay. Can then we go?
Does that mean, no, you did not do those figures for this report? Is that correct?
That's it. Sorry. Yeah. I did not do this kind of figure for a range less than 250 for this report.
Okay.
And then can we go to page 159?
Okay, wait, before we move on, Dr. Ash, while we're here, you said you did not prepare that yellow outline of dune sand freshwater capture zone. Who prepared that?
I received it from Vera Nelson, EKI.
Okay. Go ahead, Mr. Osias.
That shows up on every one of these, correct?
I believe should, yes.
And it's always in the same spot,
Yes.
and your answer
Indeed.
wouldn't change, so we won't ask you that for everyone because it's always been from Vera Nelson as she sent it to you, correct?
Correct.
Okay. Can we go to page 159? Now, in all aspects except for the location, this is the same figure, except it's measuring 500 to 1,000 milligrams per liter, correct?
Correct.
And it's in the same aquifer.
Upper 180-foot aquifer, yes.
Okay. The upper 180-foot aquifer, as it says.
Yes.
Okay. And then can we go to page 160? Whoop. And this is the same figure, except it's now measuring 1,000 to 3,000 milligrams per liter. Correct?
Correct.
In the same aquifer.
Upper 180-foot aquifer, yes.
Okay. And then page 161. Now we've changed color. We're no longer in the blue scale. We're in the red scale. Do you see that?
Yes.
And the figure is the same in all aspects other than the color scale has changed. And it's now measuring 3,000 to 10,000 milligrams per liter in the 180-foot upper aquifer, correct?
Correct.
There's no significance to the color, correct?
Correct. No significance.
Whose idea was it to change the color?
Mine.
And then page 162.
So while we're on that, why did you change the color?
Sometimes people get bored with the same color.
Okay. Go ahead, Mr. Osias.
Thank you. And now this is the same color scheme as page 161, and in all material respects is the same, but this is measuring the thickness greater than 10,000 milligrams per liter, correct?
Correct, in the upper 180-foot aquifer.
The upper 180. So if you added the thickness of all of these pages from 158 to 162, ranging from less than 500 to more than 10,000 milligrams per liter, how thick is this area that's indicated by the colored boxes and blobs? Where it's continuous, I hadn't finished, sorry. Where it's continuous and shows up on each page.
I don't know.
How thick is
I
the
didn't- I don't
upper
think-
180-foot aquifer?
Wait. Mr. Osias, he wasn't finished answering. Go ahead, Dr. Ash.
I don't know. I did not do a calculation like that. It's a good idea, but I didn't do a calculation like that.
Okay, I apologize, Mr. Lilly. I thought after I don't know, I thought he didn't know anything else.
It's okay. I just want to give him a chance to fully answer.
How thick is the upper 180-foot aquifer?
From the cross sections, I've seen it varies in thickness, so I don't know.
Now, these thickness layers are not stacked on top of each other like pancakes, are they?
This is coming out of, I believe, either voxel or grid or something. So and I'm not sure what you mean by stacked.
Well, they're not discrete layers of thickness, are they?
I don't think I would call them discrete layers of thickness. I would call it it's a distribution of resistivities converted to TDS.
Does the resistivity give you the thickness?
No. Well, no.
So I've got to interject here. This is important, and I'm trying to understand. Dr. Ash, there's some points on these figures. I think there have been about 5 of them that Mr. Osias has gone through, where there is, I'll say, an entry, a color somewhere between white and blue or white and red at the same point on all 5 figures. Not all of them, but there's some where there's an area that has all 5. And how can you get measurements of different resistivities or different thicknesses at the same point? I mean, my simplistic understanding is the helicopter is over a point and takes some data, and all that. But how can you get 5 different aquifer thicknesses for different TDS levels at the same point?
So you imagine you have a 3D grid, okay? So what you take all the airborne data, you convert it or same receive whatever, but you create a 3D grid, okay? And you have a certain cell thickness, whatever. And what you do then is you display certain ranges of data. So on these previous 4 or 5 slides, whatever it was, you display, so we have converted the resistivity to TDS data, and then you display on the screen a certain range of TDS, okay? And you apply a color scale of thickness.
So does
That's how you
that
do
mean?
it. So
Go ahead.
go ahead. No, you go.
So does that mean that the AEM data at one point can pick up different resistivities depending on depth?
Correct. That's the whole point.
Okay, sorry, I'm learning a lot here. Bear with me. I'm writing this down.
One thing I may have not mentioned when the way the data is acquired, the way that the physics works is that the magnetic field comes out from the loop under the helicopter, and it goes into the ground, and it goes down, and it's transmitting through all the different geology until it loses energy. Okay, so then what we do in our analysis, our inversion, is we use a basically a 2D or 3D grid, however you're doing it, and that grid gives you come up with cells, and that those cells are going to end up with a certain resistivity value. And so then you can then grid those data in resistivity space, or you can go through analysis, convert them to TDS, and grid them into a 3D space, and then you can come up with it, whatever the thickness range is of the whole unit, whatever of your grid. How much of that 3D grid is a range of 10,000, is a range of 500, less than 500, or whatever. And that's how it's done.
So does the electromagnetic sensor then, I mean, I do understand, well, let me ask you this. So as I'm understanding it, the test, there's the primary coil, which sends out, I'll say a magnetic field and induces certain eddy currents in the conductive layers below, and then those eddy currents produce secondary magnetic fields. So can the sensor pick up basically different secondary magnetic fields that are emanating from different depths below the ground?
That's exactly how it works.
And it can do all of that at the same time?
Very quickly, yes.
Okay. All right. Thank you for that clarification. That was not exactly obvious to me, but I appreciate your clarification.
I'm sorry I didn't explain it better.
No, it's not your fault. It's my learning. Okay, go ahead, Mr. Osas.
And in one of those points where there was continuous location of a thickness from less than 500 all the way to more than 10,000, if you sunk a well there, you would get, and pumped water, you would get 1 TDS, correct?
Wait, I think you're going to have to ask him a little more detail about where the well is screened. I think that might help with this. This is an important line of questioning, so I'm not being nitpicky. Go ahead.
That's okay, and that's what I'm trying to figure out. Could you screen a well? Because Mr. Lilly and I are interested in exactly the same answer. Could you screen a well to pick up solely the thickness of the less than 500?
Objection, not to the question per se for this hearing, but I think Dr. Ash has testified he's not a hydrologist, and without foundation that he has an expertise in well drilling in this application. I mean, I'm concerned that this question is not within his expertise that he's being brought forth to testify on.
And that objection is overruled. He can certainly testify as to whether or not he can answer the question. I think this is close enough to his area of expertise. He may very well have knowledge, and if he doesn't, he can say so. So the objection is overruled. Go ahead. If you want to ask Mr. Osias to repeat the question, that's fine.
Yeah, please repeat the question.
So I'll use a more realistic page. Let's go back to page 159. And this is showing the thickness of groundwater with a TDS between 500 and 1,000 milligrams per liter TDS, correct?
Correct.
And in some places, it's 16 to 54 meters thick.
Yes.
And if you drop a well there, could you screen it to pick up only that water?
I think there would have to be I'm not an expert in this, but I've been at aquifer testing where they put down they have a well, and then they put down different, I forgot the exact name, but they put down blocks for different zones, and then they sit there a while, then they sample that zone. And so you could move that block, so you're only getting the block of water from a certain zone, and then you could find this zone at 500 to 1,000. But it would take a while, I'm sure. It's not my area.
Is the data that created the color coding that we've seen for each of the TDS levels for this same aquifer, is that thickness data in your final report?
I would say it should be within a deliverable of the inversion result. That's what I would say.
Would it be expressed in feet? I'm sorry, would it be expressed in meters?
I don't recall if I believe it would be expressed in meters for sure. Whether it's also expressed in feet, I'm not sure.
Okay, but you believe it's in your report?
Yeah, I believe it should be in one of the final interpretive data set tables.
Okay.
We can, if you want, we could go to the 2019 report and look at the deliverable section.
So we're in it. I'm
Okay, then I would.
I'm gonna want to look at it first, if that's okay to save time.
Okay.
So we went through the upper 180 aquifer from less than 500 mg per liter up to greater than 10,000. And it was in 5 different slides, correct?
Correct.
And you did that for the perched aquifer as well, correct?
I don't recall. If it's there, it is. I don't know. I don't recall.
Okay.
I did a lot of these plots. I don't remember exactly which ones.
So let's go to page 149. Does that refresh your recollection?
So we have it for 500 to 1,000 here, yes.
Okay, and if we go back one page.
Whoops.
Nope, we don't have one for less than 500, correct?
So just scroll
Yeah.
down one page, Ms. Mullen. It looks like the first, well, at least this figure is 500 to 1,000. I don't know if we have less than 500.
Well, I'll make an offer of proof we do not. Go to the next page.
Okay, it looks like it goes up. Subject to somebody correcting us. We can't flip through this several hundred page report right now.
Right, that was, I was going to try to avoid doing that.
Okay.
And so if we also go to the lower 180 aquifer, we go to page 163. This is also the 500 to 1,000. Correct?
Correct.
And if we go back to 162, you'll see that we're now in the upper. So there's no less than 500 for the lower 180 either, correct?
Yes.
And if we go to page 167, this is now in the 400-foot aquifer, correct?
Correct.
And if we go back to 166, we're changing aquifers. So there's no less than 500 for the 400 either, correct?
Correct.
So you didn't do less than 500 for all of the aquifers. Why not?
I think it was mainly if I probably did do it, created a plot like that, and then I looked at it and I didn't see many points on it. So I didn't want to show a figure with very few points. And so to save space in the report, I didn't show them.
So very few points means an absence of thickness with that TDS quality, correct?
Correct. There were a few points. I bet there could be no points. I don't remember exactly, but there was not enough to take up space with only a few points to show on the screen.
Okay. And so just for Mr. Lilly's knowledge and to save time, from pages 149 through 170 is the sequence of these thickness at different TDS levels for the perched, dune sand, upper 80, lower 180, I said upper 180, pardon me, lower 180 and 400. And I won't take the time, but they show, as this one does, in some places a very deep, the red here is, you know, by coincidence or on this page, sort of 54 to 80 meters of high TDS water right next to the CalAmp site. Some of them so missing. So it's an important feature of the report, independent of the less than 3,000 TDS focus earlier on in the testimony.
Okay, I suspect my staff will be interested in reviewing these figures carefully. So thank you.
Can we go to back to your direct testimony? That's MC.
Yeah, excuse me, Mr. Osias. This sounds like you're shifting to a new line of questioning. So couple of things. Tell me what lines of questioning you have left and what your estimated time is. And I'm not giving you a hard time for going over because I know you had to deal with some revised slides this morning, but just tell me how much time you have left and what topics you have left.
Well, so I'll start with the topics. I have two pages of this direct testimony left, and maybe 10 to 20 questions related to it.
Okay, that's
So
all
I'm
you
not
have.
sure how long the question, I don't know how long the answers will be.
Okay, well, let's go ahead and see if you know, I do want to make sure we stop by 5. That's what I promised everyone, but go ahead and maybe we can wrap that up. So we'll go ahead to page or the exhibit MCWD 4, I take it?
Yes, we're back to direct testimony, exhibit 4.
And what page?
I'm checking here. Let's start with page 28, line 25 and a half.
I'm sorry, page 28,
Yes, page 28, line
25 and a half.
and a half.
Okay, go ahead.
And you see the sentence where it says, we also used measurements made in 7 MPWSP wells. Do you see that?
Yes.
Those 7 wells are actually 21. Each well is a cluster of 3, a deep, a medium, and a, pardon me, not, and a higher. They're shallow, thank you.
Shallow,
Correct?
correct.
Okay. And they're monitoring wells, right?
That's my understanding, yes.
Okay. So then we can go to page 29.
Okay.
So let's start up here in the paragraph. So the complete sentence starting on line 1, which says the water quality measurements were made within 2 months of the resistivity measurements. Do you see that?
Yes,
The water quality measurements were made at the time the monitoring wells were put in, correct?
I imagine some measurements were made. I assume, I don't know.
The ones used in this section of your direct testimony, you don't know whether it was the water quality measurements made at the time the wells were put in?
I don't know when the wells were put in. I know from this paragraph, the water quality measurements were made within 2 months of resistivity measurements.
Okay. And
I think the wells were put in, I don't know, 2013 or something. I don't remember. I don't know.
okay. And is the resistivity measurements those that came from geophysical logs moved through the borehole?
I believe this was actually the resistivity being referred to was the airborne EM in 2017.
Okay, so pardon me then. So, but the next paragraph seems to deal with the resistivity measurements from the boreholes, correct?
That's correct.
But that's not, that doesn't refresh your recollection that that's the resistivity measurement referred to in the paragraph above?
Let's scroll up a little bit, but I think
You have to go to the prior page, sorry.
My understanding is measurements resistivity centers of the Army determination between the resistivity measurement and scroll down a little bit, just kind of keep that first part. So, I mean, maybe I'm wrong. Maybe this is referring to that they measured water quality at a different time than they did for the logging.
All right, so I'm fascinated by the borehole logging measurements. You describe in the very first sentence starting on line 3 that there's a screened interval in each well, and it ranges, I assume that means a screened interval, between 9 and 64 meters in length, right?
Correct.
And 1 TDS value was measured, is what it says.
That's what it says, correct.
Is that true?
That's probably what the data shows.
Were you involved in this activity?
No.
Who did this?
Which part?
Took the TDS value.
Who made the measurement? I
Yeah.
believe this came from MPWSP data.
Okay, and who did the,
I'm sorry, from what data?
These are monitoring wells, so it looks like they measured water quality at a different time than they did borehole geophysical logging.
I'm sorry, but which agency? You had some acronym, I just didn't.
The MPWSP, the people who own the wells.
Okay, I don't know who MPWSP is. Maybe somebody else does.
so Mr. Lilly, that's the acronym for the Monterey Peninsula Water Supply Project. And
Oh, okay.
Those are the CalAm monitoring wells that he described on the page before as 7, but it's 7 clusters of 3.
Okay, I'm sorry. I was thinking of an entity. I wasn't thinking of a project. Thank you for clarifying, Mr. Osias. You may proceed.
Thank you. And so for each screened interval, which varied in length, a single TDS value was obtained. That's what that first sentence means. But then you also did resistivity. Actually, let me start. Someone did resistivity measurements for each of the screen intervals also, correct, Dr. Ash?
I believe they logged the whole hole, and that included the screen intervals.
Oh, but not just the screened interval.
I don't recall seeing the data, but if the screen covers the whole length of the well, then it'll be the whole well. But sometimes the screen interval doesn't cover the whole length of the well, just a certain part of it. And so sometimes they screen above and below just to make sure the system's working before they get where they want to know.
Okay, on line 4, the sentence starts, but within that screen interval, sort of suggesting it's only within the screen interval.
Again, Mr. Osias, you're mixing up TDS measurements with resistivity measurements. I think his testimony shows that they were done at different intervals.
Yes, I'm trying to figure out whether the resistivity measurements in that second sentence that starts with, but within that screened interval, it was limited to the screened interval.
The data that was evaluated for these purposes was confined to the screen interval for the borehole resistivity values.
Thank you. And for each interval, is it correct that there were somewhere between 60 and 425 resistivity measurements?
That's what it says, with a vertical sampling of 15 centimeters.
Okay, 15 centimeters is about 6 inches.
It's somewhere in there.
And were you involved in this sampling?
No, this data, again, this was probably published data by CalAm or MPWSP, both the borehole water quality measurements and the borehole geophysical logging. They were published. A report was made available at some point, and then probably Ian Gottschalk at Stanford went through, correlated where the screen intervals were and where the borehole resistivity measurements were.
So, okay, thank you. And you relied on the data?
Please clarify.
So you didn't collect the data, you said. You think it was probably compiled by Mr. Gottschalk from someone else who did it. And then my question was, did you rely on
it? Yes, looks like it was relied upon.
Well, I'm asking whether you relied on it rather than it was relied on by someone else. This is your testimony.
I relied on their study, if that's your question.
Is that the best answer you can give to my question?
Well, they did the correlation of the screen intervals from the TDS values to the borehole geophysics measurements every 15 centimeters. So I'm relying that whoever did it wrote down the right values at each 15 centimeter interval and wrote down the right values for the TDS value for each screen, and then compiled figure 12 correctly.
Okay, thank you. And then figure 12 uses, can we scroll down now? Just actually stay on this page, sorry, because it's in this paragraph. The data was used to create a histogram using the 4 TDS levels identified in your summary slides and also on page 10 of this direct testimony, rather than the TDS levels used in your thickness mapping that we saw just a few minutes ago, correct?
That's correct.
You could have created a histogram that correlated to those thickness mappings?
I could have later, when I did those thickness maps, I could have created something like that, yes.
Okay. So now let's look at the histogram, if you don't mind. That's farther down the page.
Just scroll down to lines 12 through 25. Thank you.
Apologize for the cruise ship sounding its horn in my window.
No, it's all right. I don't hear it. Go ahead.
Oh, thank you. Now, I want to understand the scales here before I ask you a few questions about this. I guess this is a histogram. Is that what I should call it, a histogram?
Yes, histogram.
Okay. So count is the vertical scale. That means how many resistivity measurements were made that corresponded to the resistivity units on the horizontal scale, correct?
Correct.
And I notice it's a evenly stepped verticality ranging from 0 to 200, correct?
Correct.
Okay. And then ohm-m, just tell me what that means.
Ohm meters. The resistivity unit is in ohm meters.
I see. And that's the resistivity unit that you mentioned in questioning by, I think it was Mr. Mock, that the lower the resistivity, the higher the salinity?
If you're dealing with salinity, that would be the case, yes.
Okay. Now, when I look at that scale, it's not evenly spaced. The gap between 1 and 2, that's 1 and 2 ohm meters, correct, is
Correct.
bigger than the gap between 60 and 80, correct?
Correct.
Can you, that's not a function of an ohm meter, right?
No.
That's a function of compiling data into a histogram, correct?
It's in this histogram, yes.
And so if you used even spacing, it would obviously be the horizontal axis would be much, much longer, correct?
It depends what you do.
Depends on the scaling, I think.
Okay.
Depends on the scaling, yes.
And if you spread it out with more detail, would there be lots of measurements that had counts of 0?
Actually, there is no resistivity of 0.
I'm sorry, I don't mean 0 on the horizontal scale. I just mean that the vertical bar would not be present. Like there might not be anything at 21.
Please clarify.
Well, I'm trying to figure out how this scale influences the interpretation of this histogram.
Can I respond to that?
Yes.
Okay. So like you said, the vertical scale is an evenly spaced linear scale from 0 to 200 in counts. The x-axis bottom scale is in resistivity, and that is plotted as a logarithmic scale. Okay, and logarithm of a base 10. So it would go from, in this case, it goes from 1 to 10 and 10 to 100. And so they don't show the 100, but that's where it's going. The reason you do that, especially with resistivity, is that very often we see very low resistivities, like your 1 to 2 here, 3 ohm meters, and we often see high resistivities, like your 50, 60, 70, 80 ohm meters. So we try to, we want to make sure that we are getting a kind of an accurate description of both ranges of resistivity by plotting them on a log scale. And that's why you see the low value resistivities are on in a kind of, you see in a larger way so we can see them, and the higher resistivities are in a log space, and 60 to 70, 80 are close together, but it also is a representation of those counts. And that's why it's very common in geophysics to plot resistivity in log space.
This is for all 21 monitoring wells that you had data for, correct?
Correct.
And so the total count in this histogram is what?
I don't actually know the exact number. Because let me clarify, are you asking about the number of geophysical measurements?
I'm asking about the total count of resistivity measurements. By my eye, utilizing the scale, it's a little more than 1,600. Does that sound right?
Professor Knight in her letter wrote about 2,000. So you're on the right scale, order of magnitude.
Oh, okay. And about 70% are from 3 ohms or less, correct?
I think it may be 64%, but yes, that's the ballpark.
Okay, so I'm doing it from this table, so I'm proud of myself. Thank you. And what percentage of count is only, so not a combined, only TDS of less than 1,000?
I don't know offhand. You'd have to look at this table and start counting.
It looks like it's about 32. Does that sound right?
I don't know. I don't know. I'd have to do the calc, look at it and add it up, and then I could say, but I don't know right now.
Okay, so there's 4 columns less than 20 each, right?
Please say that again. What do you mean by 4 columns less than 20?
So I'm asking for a resistivity where the only TDS level is less than 1,000. It's the 4 right-hand columns on the east end of the horizontal axis. And each of those columns is fewer count than 20, correct?
I don't know, Mr. Osas. I think you're missing something. The less than 1,000 are all the blue bars, and there are quite a few of those throughout the figure.
No, my question is for a resistivity that is only a blue bar. How many?
I see. Okay. Thank you for that clarification.
So less than 20 counts? I'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to 12 maybe.
That are only blue.
That's correct. That are only blue?
Yes.
I don't think there may be any. Maybe no. They're mixed.
The 4 right-hand bars are only blue, are they not?
There are, but they're not. They're less than 20. I thought your question was greater than 20.
No, I was just trying to get to a rough total of how many are only less than 1,000, not a combo.
Okay, then there's those 4, yes.
And they're a very small percentage of the 2,000 count.
Well, it looks like each one is about 10 or so, so they're about 40. So,
Okay.
Okay, let's go ahead. We're going to have to wrap up. You didn't make it, Mr. Osias. How many more questions or minutes do you think you have left?
10.
Okay. All right, we'll come back tomorrow morning at 9. Dr. Ash, I would appreciate it. I still am interested, maybe for my own technical curiosity as much as anything else, but if you can find where in your 2019 report or potentially some other document, if it's not in there, it discusses this question I asked about how one sensor can pick up several different induced secondary magnetic fields at the same time from different depths. I hope I'm saying that correctly. I would appreciate it. Is that something that may be in your report somewhere, and tomorrow you could tell me the pages where that's discussed?
it's not in my report.
Okay.
That is a discussion. There are many papers on how electromagnetics work, whether it's up in the airborne or in a borehole EM tool. I will try to find a paper that I can get for you that will describe the electromagnetic technique. All right?
Okay, that would be helpful. And then, of course, if you do, I just work with Mr. Wilkins. He knows how to transmit it to my office and make sure everyone else gets copies. So let's plan to come back tomorrow morning at 9. I don't know. I probably have 15 minutes of questions max. So we should finish. And I don't know, Mr. Wilkins, are you going to have much redirect, do you think?
I imagine there'll probably be a little bit, but not a lot.
Okay. So for City of Marina attorneys, let's have Mr. Long ready to go. We'll see how we do. But if it's, I was going to say less than, if it's before 10 o'clock, we may start with Mr. Long just to keep things going. I do have to leave tomorrow at noon for a meeting and then for travel time. But I'd like to get started if we can. Mr. Spalding, your hand is up.
Yeah, thank you, Mr. Lilly. Mr. Long has a city council meeting tomorrow. It starts later in the day, but it's a very busy day. So I think we can, if we're able to do it, I'd say by about 11 o'clock, I think that would work. But if it's later than that, he really needs to turn to the city council meeting.
Okay, well, that's certainly reasonable. And thank you for letting me know. So let's at least be ready, Mr. Long, just in case. And we'll see where we are. I mean, as you all know, these cross-X and redirect have a way of taking longer than we think. So we may or may not get there, but please be ready and we'll go from there. And Mr. Schwertzinger, there were potentially a couple of questions for you. So please be ready tomorrow for your questions as well.
Oh,
Mr. Lilly, I've got.
Go ahead. Lots of hands up. That's too bad. I wanted to wrap it up. We'll start with you, Ms. Muzine. I think your hand was up first.
no, Mr. Lilly, I did have a question. Should Mr. Schertzinger be on standby for tomorrow morning, but you answered it before I got my hand down. Thank you.
Yes, the answer is yes. You're welcome. Mr. Moore, your hand was up. Anything else?
Yeah, I'd like to make something simple. We have, I guess, some kind of dispute about the 5 consumer confidence reports, whether they're admissible or not. Mr. Wilkins, will you stipulate their authenticity and omission? Because I think we can take care of it really quickly.
I may be willing to stipulate it in the morning. I've never looked at them before, so I hesitate to stipulate without looking at them with my client.
Okay,
But
you've
I
got the
imagine
question.
yes.
Go ahead and answer tomorrow morning.
Yeah.
Okay, Mr. Betts, go ahead. Oh, did you have something else, Mr. Moore? Was that it?
No, that's it. Thank you.
Okay, Mr. Betts, go ahead.
Our site inspection for Wednesday, do we have a start time in place? I may have missed something.
The answer is no, you didn't miss something. We're still working on the itinerary, but I think just from a logistic point of view, it seems best. I think City of Marina and Marina Coast proposed we meet at the City of Marina city offices, which seemed like a good place because there'd be a parking lot. I don't want to meet by the side of the road where there's traffic danger. So my target is to meet there. We will be issuing a notice of site visit. We just haven't gotten to it. And my target is to start at 9 a.m. on Wednesday morning. We're going to go down the night before. Obviously, people can do whatever they want. I don't really want to start later than that, though, because it may take a while. And that way, hopefully, people can, at least people who live in the Bay Area or Sacramento, can get home in that day. So that's my plan. Okay, anything else? Good. We'll
Happy
be
Halloween.
happy Halloween to all of you. We will see you tomorrow morning at 9 a.m. Thank you and have a good evening.
Thank you.
Thank you, Mr. Lilly.